PostgreSQL is one of the most powerful open source databases in the world. In this tutorial, we'll start from complete basics and move step by step, ensuring you understand not only how things work but also why they work. So let's begin. Welcome everyone, my name is Akram and in this tutorial we'll build a solid foundation in PostgreSQL. This course is designed specially for beginners, no prior database knowledge is required. So together we'll install PostgreSQL, create our first database, write SQL queries and understand joins, constraints, indexes and many more. So let's see the syllabus that we'll cover for this tutorial. So here is the syllabus that we are going to cover for this beginner tutorial. We'll start with the introduction of PostgreSQL, then we'll install, we'll see some basics of SQL, then constraints, then we do some query of data, then we go through joins, then we'll see some functions and expressions, then we'll see some aggregations and grouping of queries, also we'll cover subqueries, and then we'll see views, and then we'll cover indexes, functions and operators, importing and exporting of data in PostgreSQL, and some basic administration, and then working with pgAdmin. So these things we are going to cover in this tutorial. So let's start with the first module, that is the introduction to PostgreSQL. So the question is, what is PostgreSQL? PostgreSQL, which is also pronounced as Postgres or PostgreSQL, is an open source enterprise grade relational database management system. PostgreSQL is a software system that helps you store, manage and retrieve data in a structured way. Think of it as a highly organized digital filing system with superpowers. So key points that we are going to see here is it is a relational database. Data is stored in tables. Tables can be linked using relationships, that's joins. PostgreSQL is open source. It is completely free to use and it is supported by global community and it is used by individuals, startups and Fortune 500 companies as well. Also PostgreSQL is SQL based. It uses SQL, that is structured query language, for interacting with data, and PostgreSQL is highly reliable. It focuses on correctness, consistency and robustness of data, and also it is perfect for financial systems, government office and enterprises applications. If you learn PostgreSQL, you can work with almost any major database. Now let's see the reasons why we should choose PostgreSQL. So the first thing is it is open source with no licensing cost. PostgreSQL is completely free, no hidden charges, no enterprise fees, no licensing drama. So this makes it perfect for students, freelancers and large organizations as well. This is also highly reliable and stable. It is ACID compliant. ACID means atomicity, consistency, isolations and durability, and it is also designed for mission critical systems. For example, banks, government agencies and large e-commerce companies often use PostgreSQL because they cannot afford data loss. PostgreSQL can be customized. You can add new data types, functions, even entire language. It also provides strong SQL support. Some databases claim to support SQL, but PostgreSQL implements it correctly and consistently. It supports subqueries, window functions, common table expression, that is CTEs, and also full text search. PostgreSQL is both a relational database and can act like a NoSQL database. The features such as JSON and JSONB data types, indexing on JSON, and faster for mixed workloads. So this is a huge advantage over MySQL database. So here are some advanced capabilities of PostgreSQL: concurrency and MVCC. MVCC stands for multi-version concurrency control, which allows many users to read, write data at the same time without blocking each other. So it's like allowing multiple people to read the same book while someone updates a new edition without disturbing anyone. Another advanced capabilities of PostgreSQL is powerful extensions. Powerful extensions such as PostGIS, pgCrypto are also supported in PostgreSQL. Extensions in PostgreSQL are like plugins that add superpowers to PostgreSQL. PostgreSQL provides multi-platform support. It works on Windows, Mac OS, Linux as well, and also it can run on cloud platforms such as AWS, Azure, etc. So here are the comparisons between PostgreSQL and the competitions in the market. So the first thing is cost. PostgreSQL and MySQL licensing cost is free, but Oracle is very expensive. And SQL standards, PostgreSQL is very high, MySQL is medium, and Oracle is high. And extensibility, PostgreSQL is excellent, which is its one of biggest feature. MySQL it is limited, and in Oracle it moderate. And PostgreSQL is best for complex application, MySQL is for simple application, and Oracle is best for large enterprise. So in summary, MySQL is good for simple websites, Oracle is better for security concern projects, whereas PostgreSQL is best for complex applications that need accuracy and advanced queries. Now let's understand the high-level architecture of PostgreSQL. PostgreSQL architecture may look complicated at first, but at high level it's very simple once you understand the main parts. So there are layers: client layer, server processes, shared memory, background processes, and storage layer. So let's understand them with a diagram. So this is a high level architecture diagram of PostgreSQL. At client layer, we have pgAdmin, we have PSQL command lines and applications such as Python, Java, Node.js, etc. So clients send SQL commands to the server. And then we see PostgreSQL server, which is the brain of the PostgreSQL. So this is the core PostgreSQL engine. It receives SQL from client layer and processes it and returns the result. So the server includes few things such as parser, planner or optimizer, and executor. So it understands your query, creates plan, executes it, and send back the output to the client layer. So there is one more component, which is shared memory. Shared memory is where PostgreSQL stores information that all processes can access, such as cached data and buffers. So components of shared memory are shared buffer, WL buffer, that is write ahead log buffer. We'll see these things in some time. There is one more component of PostgreSQL, which is background processes. PostgreSQL doesn't work alone. It has several helper processes running quietly in the background to keep everything fast and fine. So for examples, WL writer, that is writes ahead log writer, background writer that manages the cache memory, checkpoint processes that ensures data is stored safely, auto vacuum that cleans older data. So you don't need to understand everything now, just know that these processes make PostgreSQL stable and reliable. So there is one more component, which is storage layer. So this is where PostgreSQL actually stores the data, that means in files on disk. So important part of this layer is tables, indexes, WL, that is write ahead log. So write ahead log ensures that even if your computer crashes, your data is safe. So you now understand that what PostgreSQL is, why it is trusted worldwide, how it compares to other databases, and how its architecture works at high level. With this foundation, you are ready to dive into installation, setup, and real SQL operations. So let's move to the next module, that is module 2, installation and setup. Hello everyone, in this module we are going to install PostgreSQL on Windows and understand all the major components, set everything up, and finally create your very first database using pgAdmin tool. So for this tutorial we will continue to use Windows OS. So let's get started. In the first part we will install the PostgreSQL in your machine. So for that you need to visit to this website. So I provide the link in the video description. You can directly open the link and come to here, and as per your machine configuration, like for me it's Windows, so I'll download the latest version. So this is how I can download using this click. So I have already downloaded and saved it in my machine, so I'll continue to install it. So you can pause the video and complete the download, and then we can go to installation. So let's start the installation. So right click on the downloaded file and then click on open, or you can enter. So the installation has started. Click here on next, then select the path. For me this is applicable, and then click on next. You can change for yourself. Then you can select what to be installed. So as of now we are selecting everything. Then select next. Then this is the directory where the data will be stored. So this is the default place, and then next. So this is the summary of installation. So you need to remember that how we are going to install it. So then click on next and the installation should start. So the installation has started. You can pause the video and complete the installation and then resume the video. The installation is about to complete. the uninstaller is getting created, so we are at the very last step of installation. So the installation is completed. So for now you can uncheck this one and finish the installation. There are some extra tools that we may need later but not in this tutorial. So when we need that, we can also install them. So uncheck that box and click on finish. So the installation is completed. Once the installation is completed, we can use pgAdmin tool and connect to the server. So here we can search pgAdmin. So this is the pgAdmin application. Open it. So while doing this, you might face some issues, installation error, setup error, so you can write them in comment box. I have already made several videos on these topics, so I can help you setting up the PostgreSQL properly. So the pgAdmin is getting started. So at the left hand side you can see there is a server, so expand that one. So here you can see there is server PostgreSQL 18. So the password I had said, it is root password. So put the password and click on OK. So the server is now connected. Okay, so this is how we can install the pgAdmin and PostgreSQL server through this application. So if you face any challenges while installing or anything, you can just let me know in the comment section. I'll try to help you out. And now let's understand some PostgreSQL components. So first thing is PostgreSQL server that we have now seen here, that is PostgreSQL 18. So this is the actual database engine. It stores your data, runs queries, handles securities and manages all database operations. So in simple words, it receives SQL queries that user provides, it processes them, then it returns the results, and also it manages the users, roles, permissions, etc., and stores all the database on the system. So you can think of it as the brain of PostgreSQL. Now let's see pgAdmin. So pgAdmin is a tool, it's not the database, it's a tool that helps interacting users or you as a user of a database with the database system to the server, that is the PostgreSQL server in our case. So pgAdmin is a GUI tool, basically a visual interface that makes it easy to work with PostgreSQL. Instead of typing everything in the terminal, you can create database, write queries, monitor server performance, view tables and modify schema. So pgAdmin is the dashboard for interacting with your PostgreSQL server. This is how pgAdmin looks like, and going forward we'll explore more about the pgAdmin tool. Now let's create your first database. So the pgAdmin is ready and we have connected to the server. So for that you can expand this one, go to the server section and select your server, that is PostgreSQL 18 in our case, and then select the databases and right click on the database, select the create and then select the database. Here you can give one name. So for example, it is first DB, say this is the database name that I'm giving, and I'm not touching anything else, just this much, and I'm doing the save. Click on save. So congratulations, now you have created your first PostgreSQL database, that is called first DB. So you can create your objects such as tables, views, procedures, functions and so on within this first DB database. And also one thing you need to remember is that whenever you are creating one server, automatically one Postgres database is also provided to you. So here is the Postgres database, that is the default database. This is provided by Postgres. If you don't create any database or mention anything, so by default all your objects etc. will be created within this Postgres database. Now let's quickly see some basic pgAdmin navigations. So this is the browse panel that we have on the left side. So if you see, we have servers here, we have within the server we have databases, we have within the database we have schemas, within the schemas we have, if you see public schema, by default schema is public. Again we can create as many schema required for our database operations within the database. So by default public is provided, so we are not creating any other schema, but it is here. So within that schema we can create all our objects here. We can create table, we can create procedures etc. and so on. Now there is one more option, that is the query tool. So this is the query tool. So you can click here, the query panel will be opened up, and here we can type all our queries, etc. We can perform, like suppose we can say, we can like this one, this is a simple one, select version. So we can do this much and we can see the current database version. So execute this one. To execute this, you can click on this thing, and here we can see that this is the Postgres version that is currently we are connected to. And that's all for module 2. That installation and setup is completed. Now you have PostgreSQL running on your machine, you understand pgAdmin, and you have created your first database, that is first DB. In the next module we'll dive into SQL Basics and start creating tables. So if you found this helpful, don't forget to like the video and subscribe for more PostgreSQL tutorials. See you in the next module. Hello everyone, in this module we are jumping into the core of the database work, that is SQL Basics. By the end of this module you will know how to create a table, insert data, read data, update data, delete data, and drop tables and databases. So basically everything you need to properly start working with PostgreSQL like a real developer. So let's get started. The section 1 is, so the question is, what is SQL? SQL stands for Structured Query Language. Also some people prefer to say it SQL. So SQL is standard language used to communicate with a relational database like PostgreSQL, MySQL, Oracle, SQL Server, and others. So SQL helps you store, retrieve, manipulate, and manage data. Okay, so think of it as talking to PostgreSQL using English like commands. So there are proper syntax how you need to provide a command to the PostgreSQL server so that it understands your query and perform the actions. So for example, if one syntax I say, this is select, then star, then from, then we need to provide a table name, say students. So this is the syntax to retrieve all the students information from the students table. Okay, so this is how we write. So this has a fixed format. So if you deviate it, if you write like select, from, then star, then student, so it won't work. Okay, so it provides you a specific syntax, that's the grammar we say. So you need to write your commands like that only. Okay, so this sentence literally means that what we have provided, you are saying, hey PostgreSQL, show me everything from the students table. Here everything means every column and every records. So how we are going to filter that? We might not need all the columns or all the records all the time. So how we can filter them? We'll see them going forward. So now let's see some data types in PostgreSQL. In PostgreSQL, every column in a table must have a data type. Okay, so here are the most common ones that you will use as a beginner. For example, there are data types such as integer, you can say. Okay, integer data types. The data types can be serial data type. The data types can be numeric ones, such as it can be whole number or it can be decimal number as well. So integer holds the only whole number. It can hold like 1, 2, 3, maybe bigger number, and so on. The serial number we usually create for auto incrementing purpose, like when we create some IDs such as student ID. Okay, we want student IDs to be generated in serial and automatically. Okay, and when we say numeric, it can be your marks, your average, it can be 98.56, like that kind of thing. When we want to store, we use the numeric and we provide the precision and the range of the numbers. So these were some numeric data types. There are also text data types, such as we can say varchar is there, and then when we mention varchar, we mention also length, that how much size of the string that can hold. So this is a varchar 10, that means it can store data up to 10 bytes. That means in simple word, it can store 10 characters of data. Okay, so there is one more very famous data type, that is text. This also holds all the text, but there is no limit how much you can store. Okay, and the first one, varchar 10, we used to store only 10 characters, but in text that's not limited, we can store unlimited data. Now let's see some date and time types. That is one thing. One data type is date. It stores only date portion. It will not say type. If I select one column as date, it will save the data as, say, for today it's 25th of April and 2026. It will not say the time. What's the time now? It's 4:27 p.m. But that will not be stored. But to store that, so we have another data type that is called timestamp, that stores date plus timestamp as well. So in a situation where you need to store both time and date, so better to go with the timestamp data type, and where you need to store only date, so go with the date data type. So there's one more good data type that's called boolean. Okay, so boolean data type, it stores either true or false. Okay, so going forward we'll see the examples obviously, but understand this boolean data type. Boolean data type stores true or false. That means if one thing is true or false, it cannot hold other things. So we can have some columns like maybe say name, varchar, and we can say of 20. So the name can be of 20 characters, and then maybe we can say price. This can be of, maybe we can say 12,2. Okay, price can be of 12 length and 2 decimal points. Then we can have like created date, we can, and the data type should be date. So this is how we use the data type in PostgreSQL. Okay, and now let's see how we create and manage schemas. So in the previous module we said that there was schema. So schema can be public schema, which is default schema, but we can create schema as per our requirement. So a schema is like a folder inside your database where you organize tables or other objects. By default, PostgreSQL uses something called the public schema that we saw, that we are creating tables and we have expanded here. This is the public schema. Okay, so but we can create other schemas as well. So for now we are creating schemas within our firstdb database. Okay, so there is a database called firstdb that we had created in the previous module. Within that there is a schema called public schema, so which is the default schema, and then we are creating a new schema. So to create new schema there are two ways. We can, obviously this is a GUI tool. You can just right click, go create, and perform create schema. So we can give one name, maybe we can say school. So this is the schema name. Then click on save. The schema school will be created. So done. The schema school is created. Now to use a schema we need to set the search path. There is something called search path. By default, if you see, there is called something search path. Okay, when you are connected to database, for example say the first DB, you have done the default connection and you haven't defined any schema, the searching or the finding of the objects will be done within the public schema. Okay, so going forward when we do stuffs using other applications such as PSQL tool, dbeaver, etc., it will be clear why we use the search path operation. Okay, so now we have created a schema called school, but we haven't using it. So to do that you need to write this set search path, then to then your schema name. So here in this case this is school, so you need to execute this query. So this is set. Now whatever we are going to do, it will be done within the school schema, not in the public schema. So this basically tells the PostgreSQL to look inside the school folder of the tables, not within the public. Now let's create tables. So as we have created schema, within school schema we are going to create some table. Now let's create our first table called students. Okay, so for that we know that the command should be create table and then students. We haven't created the table yet, so we are going to create. So this is how create table works, and then open parenthesis and close it, and then write the column names here. Okay, so the first column that we are going to create is student underscore id, and we are going to define it as serial. We know that serial keyword will generate automatically incremental value. Okay, and we are defining it as primary key. So what is primary key and so on, we are going to see them later in advanced thing when we cover the constraints in later module. Okay, so it prevents you from entering duplicate values basically. So now we are creating one column called name, and we are defining varchar, and we are providing the size of that column is 30. Okay, and then next one column we can add age. Okay, age we can provide integer. We know we are going to store age like maybe say 14, 15, 19, 20, 25, etc. and so on. So we are not taking it in decimal, but we are taking it numeric value. Only whole numbers will be stored. And then we create another column called grade. Grade we are going to store in maybe say varchar, and we can say 10 is enough. So we can create this one. Okay, so we have done with this one. Now let's select this much and click on execute. Okay, now I have figured it out why it was giving error, because we had created the school schema in caps which was not recognized in Postgres. So better you can drop that schema like this, right click on that created schema, then drop cascade or simple drop. So you can drop the school schema that you had earlier created. Now again right click on the schemas and then go to create schema and then select school like this and then click on save. So here you can see the school schema is created. Now expand this school schema and then open the query tool. So here you need to set this one, set search path to school as we have discussed, and then go and create table school students, then the table should be created. So now you can see the table is created within school schema. So how you can verify that? You can just scroll down to table section, refresh this one, right click on tables and refresh, and then if you expand this you can see the table. So this is how we have created our first table in PostgreSQL. Now as we have created the table, now let's go and insert some data into the table. So to add the data into the table we use the insert command. Insert command is this one. Okay, so there are some ways to insert the records, but we'll use simple ways how to do this. So the simple way is to write insert, then keyword into, then tables, the table name, and then the column names. So the column can be name, the column is age, and the next column is grade, and then the keyword is values. You can write everything, the keyword, you can write the keywords in uppercase or lowercase or mixed, it doesn't matter, because SQL is case insensitive language. You need to remember this. SQL in it can be in PostgreSQL, it can be in Oracle and so on, but it is case insensitive. Okay, so you need to provide the values, as I can provide the values like this. Name is Akram and age is, we can provide the age like this, since this is not a string, and grade, this is a string, and we need to provide like maybe we can say A grade. Okay, here if you see I'm not providing anything for the student ID because I have declared it as serial and primary key. So since I have defined it as serial, the values will be generated automatically serially. So let's try to insert the record and see. So the record is inserted into the database. Okay, and we can see that writing like this, select star from then students. So this is how we can select the data that what we have inserted. So one record is returned, that means we have inserted our data properly. Similarly, there is another way how to insert the data for multiple records. So let's copy this one and edit this. So for example, there can be multiple records to insert at a time. You can say like these values, and then you can say Vivek, and is maybe 24, grade A, and instead of writing here semicolon you can write comma, and then you can continue providing values. The next record you can say Prem, age is 28 and grade is B. Okay, and so on. You can just put comma and write the next values. So we are inserting now two records at a time. So this also should work perfectly. So here we can see that two records inserted. Again we can verify them. So select star from students and execute that. So here is the result. So as of now we have inserted three records into the table. Okay, now let's see how we can select the data. One selection we have seen, that select star from tables. That means we are saying to the PostgreSQL server to give me all the records from the students tables. We are showing all the columns, but this is not the case going to happen for all the time. We might need some columns for some record and so on. So for example, say we need to see specific columns. In that case, right select and write comma separated columns. So for example, say I want to see age first and then name. So you need to write like this, select age comma name. You can write then from then the table. Okay, so this will return age and name of all the students. Okay, so this is how it works. And also we can filter the data. How we can filter? We can filter the data based on some condition. Maybe we can write like this, select star from students. That means we are saying PostgreSQL server to return all the records for the students, or sorry, all the columns for the students table, where this is the keyword where. What is the condition can be based on any column. Okay, so for example, let me provide the column condition such as age is greater than 25. Okay, so we know age greater than 25 is for Akram and Prem. So these two records with all the columns should be written. So let's see. So here is the answer. Okay, so if we are trying to filter out data, it can manage. So here we can filter out the data, how many records we are going to insert. So this is how we can filter the data to see how many records we need in a result. So combining the both, that is selecting age and name of the students with a particular filter. So we can also have this thing. So that means we can have selected columns and selected records. So it's not mandatory to have everything in your output. So here we are selecting only age and name for the students where age is more than 25. So this is the answer. So this is how we select the record. Okay, now let's move on to see the updating the data. So updating means to modify the data. To modify the existing data, we use the update command. This is the update command, okay, or update keyword you can say. So for example, say we are going to change the age of Prem. Okay, so how we do that? So for that we can write like this update and then the table name. So this is the syntax, update table name, and then we need to write the keyword set. Okay, then we need to select the column. So which column we are going to update? We are going to update the age. Okay, and also we can at a time we can change many things obviously by comma separated. So for example, say age we are going to make 29, and maybe we can change grade as well to, maybe we can say grade C. Okay, so how do we select Prem? So I had explained you, we can select all the records first to see the primary key. So this is one thing that you need to remember, that always when you are doing any update, prefer the primary key to update the data so that you don't do any faulty update. Okay, because we know primary key will be unique throughout the table. So these things we will discuss later when we cover the topic of constraints. Okay, so here we need to provide the condition. On what condition we are going to update the data. So where student ID equals to, for Prem it's 3. So this is how you are going to update. So Let me explain again. So here we are saying that update students table. We are asking PostgreSQL to update the students table, and what to update. So we are providing set age should be 29 and grade should be C. So for which record we are going to update? If we do this much only and execute, so it will set for every records. So if you have 3000 records, so everything will be updated, but we don't do that usually. We always do update with where clause. Okay, so where student id 3, that means we are going to update the record from prem. So current data is for prem age 28, grade B. So it will be updated as we have provided. So let's update. So the data is updated. Now we can confirm the same thing by writing select star from students. So here we see that prem is updated with age 29 and grade is C. So till now we have seen how to insert the data, how to update the data, how to select the data, and now we'll see how to delete the data. Okay, so deleting the data means to remove the data from a table. So for example, we can see, okay, so to delete the data, this is the command delete keyword. Okay, just like update, this is the update keyword. For delete, it is a delete keyword. Okay, so let's delete one record. Delete from, this is the keyword, this is the syntax. Delete from the table name. The table name is students. Okay, and what to be deleted? If we don't write any where clause, it will delete all the records from the students table. But we always should provide a where clause. That means to filter out, to let the PostgreSQL know what to delete. So write where, then similarly we can say where student id equals to 3. That means we are going to delete the data for prem. Okay, so if we perform this much, so it will delete the record from the students table, and the deleted record will not be present in the table. So let's delete. So the data is deleted. Again we can verify how the data is present now. So select star from students. So this is the data now. So prem's data is deleted because we deleted the data. And as you know, if we remove the where clause from the delete, it will delete all the record. So I'm not taking that chance. You can try it out. Now let's see how to drop the tables and databases. So here we have created the table called students. Okay, so to drop the table, what to do? To drop the table, there is a command called drop. So this drop command is almost used for every dropping object. So drop table, since we are going to drop the table, then students. So this is the command. Also you can use the GUI, that is the pgAdmin. Right click on the students and then do the drop, and it's asking for dropping. You can select the drop, or you can also drop by using the command drop table, then table name. So let's drop this. The table is dropped. Now if I click on table section and refresh it, that student tables is gone. Okay, that means we have removed the table. Similarly, we can also remove the schema. We can also remove the database as well. So let's remove the database itself. That means the schema as well removed, because schema is present within the database. Okay, so there are two ways. You can right click on this database and drop or drop force. Drop force means it will drop by force even if there is dependency. Okay, so if you can select drop and drop like this, you can also do. But to use the command, you can write like this: drop database, then the database name. What the database name? This is first DB. Okay, so this is the database name. So if I execute this one, so this database will be removed along with whatever we created within the database. So be very careful while doing this, because when you drop table, only one particular table is dropped, but other tables are saved, they are not impacted. But if you are dropping database, that means you are cleaning everything. Okay, so this will be done permanently, and it will not be rolled back. So because this is a DDL command. So let's do. So the database cannot be dropped as this is opened here, because we have opened this session, hence this will not be dropped. So let me clear everything and close this one. So since we are not using the first DB, now we can drop this. Okay, so let's drop the database. So the database is dropped. So this is how we create database, we create schema, we create tables, we insert data, and we perform everything, and finally we dropped everything. So that's all for module 3, that is SQL basics. You now understand the essential SQL commands needed to work confidently in PostgreSQL. So in the next module we'll go deeper with the more advanced SQL things, and filtering, sorting, and working with constraints, and etc, etc. So let's move to the next module. In this module we are going to talk about one of the most important concepts in SQL, that is constraints. Constraints help keep your data accurate, reliable, and clean. Without constraints your database becomes a garbage. So with constraints it becomes a well managed system. So we'll cover all major PostgreSQL constraints with clear examples. So let's get started. So the question is, what are the constraints? Constraints are rules that applied to tables and columns that control what type of data is allowed to be stored. Okay, they protect your database from invalid, inconsistent, or duplicate data. For example, you shouldn't insert a student record without an ID, or you shouldn't store an age as a negative number, or you shouldn't enter two users with the same email. So constraints prevent all of these mistakes. So first we'll start with primary key constraints. So the first type of constraints that we are going to see is primary key constraints. Okay, so what is primary key? Primary key is basically unique key plus not null constraints. So in some time we will cover them as well, not null constraints. So this is the mix of constraints. So a primary key uniquely identify each row in a table. So it automatically applies not null, that is not null means at least one value is required, you cannot leave it blank. And unique constraint, that means all the values should be unique in that field. Okay, so for example let's create a table first. Create a table, then say students table we are going to create, and will provide some columns such as student ID as serial, and here I have mentioned primary key. Okay, so this is how we define the primary key, that this column has to be primary key, that means it should be not null and also unique. So the next column is character varying, and we can define it, maybe say 30 for name, and age is int. Okay, so int is also one of the data type, that's numeric data type that stores whole integers. So let's create the table. So the table is created. So what we have done here, we have taken student id as serial, and it should be having one value, and those values should not be duplicate. Okay, each value must be unique. So if I give you one real life example, it would be a primary key is like your maybe Aadhaar number, it can be like your PAN number, so where no two people can have the same one. Okay, so this is how primary key works. Next type of constraints we will see, it is foreign key constraint. Okay, foreign key constraints. So foreign key constraint links one table to another. It ensures relationships between tables stay valid. Okay, so for example we'll create another table here. Let's say create table departments, and we'll take columns such as department id. Department id can be serial and primary key, and then we can take department name. We can take it as maybe we can say text. Okay, so and then we can create the table. So this table can be created like this. Okay, so departments table is created. Now let's create another table called employee table. Okay, so I'll create table employees, and I'll have columns such as MPID, which is again serial and primary key. Okay, because this has to be unique in employees table. And then I'll take employee name, that is again text, and then I'll take the department ID. Okay, so since here I am taking department ID, it has to be the department ID has to be the same that we are taking here. Okay, so that means if we don't have department ID, any department ID, say department ID 10 in the departments, so we should not be able to insert that department ID value while inserting data for employees. Okay, in a moment I'll show with examples as well. So let me define. So this is the normal column we have defined. Now we'll start defining the foreign key. Okay, so for that we have this keyword references. So references to what? References to departments table department ID column. Okay, so it references like this. Okay, so let me create this table. Okay, so there's a mistake in the departments. Okay, so the name should be same because it looks for that table. Okay, so the employees table is also created. So here we have defined the foreign key. So that means for every employee's department ID must match an existing department. You cannot assign an employee to a department that doesn't exist. You also cannot delete a department if employees are still linked to it unless you use cascading. So we'll see in upcoming videos what is cascading. Now let's understand this one with example. Okay, so what I can do is I need to insert some department. Maybe say I'll insert into first employee table. Okay, as of now we don't have any data into the department table, so let me insert employees table, and in the employees table I can provide employee name and department ID, and in the values section I can provide department name, maybe say Akram, and department ID, any department ID, maybe say 10. I'm providing this one. Okay, so this shouldn't be inserted because the department ID 10, there is no record with the in the department table with department ID 10, so that should not be inserted. So let's try. So see, this gives error that says violates the foreign key constraint because there is no department ID with 10 in the department table. But if we insert the department, maybe say I can insert into departments, and the column that we had for department, it's only department name. Okay, here I need to provide department ID because I'm providing 10 department ID, and department name maybe say IT. Okay, so I can insert these values. Okay, so sorry, so this is 10 and this is ID. So I can do, so I can insert values like this because if I don't mention any columns, so automatically I need to provide all the columns values serially in that format. So one data is inserted into the department table. Now if I try to insert this one, so this should be inserted. So let's see. Yes, now we have, so now we are able to insert the data into the employees table because we already have one record in the departments table with department ID 10. So this is how foreign key constraints work. Okay, now let's understand another one, that is the unique key. Unique key constraints, we'll see how it works. Okay, that is a unique key constraint. Okay, so unique key constraints ensures that all values in a column are different. That means unique. Okay, so for that I can create one table, create table, say users. Okay, in the users table we can create columns user ID. User ID, again it is serial and primary key. Okay, then next column we create its email. Okay, so for email we know that email should be unique for everyone. Okay, for all the users email should be unique. So how do we manage that? So we need to define it as unique. Okay, so it will take only unique values, it will not take the duplicate values. And also we can define another one, such as say username. Okay, username also we can say varchar maybe 20, and I want username also to be unique. Okay, so like this I can write. Okay, so I can insert, I can now create this table, create table users. So the users table is created. So the common use cases is that you cannot insert two users with the same email or same username. Okay, so in how it can be used for uniquely defined emails, phone numbers, username, license number. As I said earlier, it can be Aadhaar card, it can be PAN card, etc. Okay, so now let's see not null constraints. There's another type of constraint, not null, that we saw at the beginning of the constraints, that is primary key is unique plus not null. So what is not null constraint? So not null means it prevents a column from being empty. You cannot leave the column empty, you have to mention some values. Okay, so let's understand with an example. Maybe say create table products. Okay, so I'll have some column for products and maybe say product ID. Again it is serial and primary key, so because product ID has to be primary key and uniquely defined. And then I'll create one column product name. Okay, product name is this, and I can say varchar maybe say 30, and I'm defining it as not null. That means I cannot leave the product name blank. Okay, so I'll show you with example how we can do that. And then I may have another one such as price. Okay, price column I also have, which is numeric, maybe say 10 comma 2, and also this is not null. So that means when I insert one data into the products table, so by default primary key will be generated, so I cannot have it null. Product name I have defined is as not null, that means I have to provide some values into this. And then I have price column, which is also not null, that means I have to provide some values. So let me create this table first. So the table is created. Now let me try to insert data. Insert into products. Product ID I don't need to provide, so product name and then price. Okay, so in the value section, maybe say product name I have provided, it can be books, and maybe product price I am providing it null. Okay, so let's see what happens. So it should give me error because I have defined product price should be not null. Okay, so now it says that it violates the constraint and it is the not null constraint that is violated. That means I have to provide some values. Again, if I say provided this value as say 100.5, okay, but I don't provide anything here, maybe say I can do it null, so still it will give me error because I have defined that product name also cannot be blank. So see, again it violates the not null constraint and it gives error. But if I provide all the values, then the data must be inserted. So let's try. So see, the data is inserted. So not null constraint, that means value required, and as I said already, primary key columns automatically have not null constraint. Okay, plus unique key constraint. Okay, not null constraint is completed. Now let's see another constraint, which is check constraint. Okay, so this is also a very important constraint. This ensures a value meets a condition. Okay, so there are many examples, like we can say age cannot be negative. If I just define age column as numeric and something, so there's possibility that it can have negative number, or some maybe say salary must be above a minimum wage, or maybe quantity of product, or quantity of or we can say price of a product must be greater than 0, etc. So this kind of constraints or checks that we do it using check constraint. Okay, so for that we can take the example of maybe say I can create the uh, table again, say create table employees, so I'm writing in short, and then I can have like column like this, employee ID first, it is as usual serial and primary key. Okay, and then I have one column, say age is integer, but I need to limit the age. What should be the age of employee? As we know that under 18 age of people cannot be workers. Okay, so I need to restrict that. So how I do that? So I need to provide After the data type, I need to provide as integer, and then I need to write like this: check, and then what to be checked, what's the value condition. Okay, the condition should be age value that we are providing here. Age value must be greater than or equal to 18. Okay, and also I can write another one like or. Here we can write multiple things. So age should be less than equal to 60, because more than 60 age of people should not be allowed to work. Okay, so this is how check constraints work, and I'll show with you examples as well. So let me create this is, I think this is enough to understand. So let me, otherwise I can say another column, say gender. Okay, gender, I have provided varchar, and I have provided maybe one is enough, and I'll provide check. Okay, check gender should be gender should be gender should be how should be gender should be either male or female. Okay, gender in, it can be M or it can be F. So that means if I try to insert any value other than M or F, it will give me error. So let me create the table first. So the table is created. Now let's try to insert some data to understand this. Insert into employee values directly. Okay, so in values I need to provide employee ID as well. So employee ID 1, and age, let me first give one correct insert. Okay, maybe 20. Okay, 20 age is valid because it is more than and equal to 18, and it is less than equal to 60. Okay, so this is a valid age. Now let me say age is, sorry, gender is M. Okay, that's male. So let me try to insert, and it should get inserted. So the data is inserted, and if I modify this to maybe say female, so this also should work. Okay, okay, so it says that unique key violated because I have provided the 1 as well. So let me make it 2. Okay, now it should work. So that data is inserted, but if I change it little bit, maybe say I did it lowercase. Okay, so I have provided it in lowercase, so it will not be inserted because it violates the check constraint. So the data is not inserted, and it says that employee gender check is violated. Okay, so because we have provided in the check that the value should be exactly like this. Okay, so this is how we work with check constraint. And now also if age I provided maybe say 61, which is more than 60, so it will also be violated. No, this was not violated because here we have a mistake that we have defined OR condition. It should be AND. Okay, that means age must be greater than equal to 18, and it should be less than equal to 60. Okay, then only it will have proper range. So you can correct it and try it again, so it will work. Okay, so this is how we use check constraints with the examples we see, and also you can try with other examples as well. Now let's see another constraint, which is default constraint. Default constraint automatically provides one default value for a column, or as we defined it. Okay, so it automatically inserts a default value if no value is provided for that column. So let's see with examples. Maybe say we can say create table, maybe we can say take orders. Okay, and orders table we create with order ID, serial, and primary key. Okay, so I have defined order ID as serial and primary key. And status maybe I can say varchar, and I can say 20. And the status, if I want any values. Okay, so I want, if no value is provided for status, the value should be one default value. So here I need to define default, and I need to say it as maybe say placed. Okay, so when first time order comes, obviously it will be order placed status, so I'm providing like that. And also I can write like this, maybe another column I can take order time. Okay, at what time the order was placed. So first I need to define the timestamp, that is, this is the timestamp. And also here I can take the default, and default what can be, it can be now. So this is a date function, so when we cover the date functions, etc., I'll explain this one what is now. So basically now gives you the current date and time. Okay, so let me create this table first. So the table is created. Now I'll try to insert the data into the orders table. Okay, so let me try to insert into orders. Okay, now I don't write anything. Why? Because I know order ID will be generated automatically. Status, I have a default value. Order time, also there is a default value. So what I'll say, insert into order default, then values. Okay, so I don't provide any values, but I mentioned that it should take default values. So the data is inserted with the default values. Now let me try to say those values. Select star from orders. So I can see here that first order is created with order ID 1, status is placed, and this is the timestamp at what time the order was placed. So this is a way to provide the values, but there are other ways also. So what I can do is I can write like here, maybe insert into orders, then I can say I have provided status only. Let me provide only status and values for the status I can provide like done. Okay, so there are two columns that I am not providing any values, that is order ID. I know it will be generated automatically because it is defined serial, and order time. So order time will be generated automatically the current timestamp. So let me insert this data. So the data is inserted and I can check the data from the orders table. So here you can see that order ID I hadn't provided anything, so it generated automatically. The same thing happened with the order time because I have provided a default value, that is the now, that means current timestamp it should take. So this is how default constraint works, and they're very useful for timestamps, status fields, flags fields such as true, false, etc. And now let's see combining all multiple types of constraints that so far we have covered. Okay, so we'll take an example of table creation where multiple types of constraints will be there. Okay, so let me create one table. Say create table, maybe I can say accounts. Okay, accounts table I'm creating. So here I take example of say account ID, which is serial and primary key. So here we have used primary key. So now let's see other one. Say email, I can use email ID I can take, and email can be say varchar and 100, and this email should be unique and also not null. Okay, so this is how also we can define. Why? Because we know in case of unique, if we provide only unique, so it will allow the null values, but what we want, the email should be not null, that means it cannot be blank, and as well as it should be unique. So in that case we can define this one. Okay, so you may ask that why we cannot define it directly primary key, because primary key is the same. Okay, that means primary key is unique and not null. So here is the thing, that in one table there can be only one primary key. Okay, so this is very important to remember, we cannot define more than one primary key, okay, in a table. So here for email we have utilized unique and not null. Okay, now let's use, we can say check constraint. Okay, check constraint, how we use, maybe we can say balance. Okay, balance we can say numeric, and we can check that balance should be, maybe say balance should be greater than equal to 1. Okay, so you cannot have a balance less than 1. Okay, so this is one check constraint, and also I can define default on it, default, and it should be default 1, or maybe I can say if balance is more than 0, and same goes for this one, default should be 0. Okay, so that means it will prevent you inserting any negative numbers into the balance. Okay, so balance cannot be negative. So this is how we did. So we have utilized primary key here, we have unique email, we have not null email, that means email cannot be null, and balance cannot be in negative, and one starting point, that is default 0 is given. So let me create this table. So the accounts table is created. Now let's insert some data into this. Insert into accounts. Okay, let me check the name accounts, and then I can say values. account ID 1, email I can provide like say akram@gmail.com. Okay, and this is a valid insert first time providing, maybe say 10. Okay, so these values should be inserted. Why? Because all the values that we have provided that satisfy the condition. Okay, so the value is inserted. Now let me modify this one. I'll modify this one to maybe say 12, but it will not be inserted because we know that one email ID with this one account already exists. So this will restrict me inserting the data. So see, so it says that duplicate key violates unique key constraint. So account email key. Okay, so that means email is same. So if I make it 2, so now it should work. Okay, so this is inserted. Again, if I try to insert, maybe say I have provided it, so it should be greater than equal to 0. So if I do -1, okay, and maybe say I'll make it 3, and this one is 3, so this one cannot be inserted. Okay, see, this is not inserted because it gives error that account balance is in negative. Okay, so if I make it positive, maybe say only 1, it should be inserted now. Okay, this is how it works. And if I don't provide any values for this balance, what will be the value? The value should be 0 because we have defined the default value as 0. Okay, so you can try that one. Try to insert the data without the balance value, so it should be inserted with 0, but in that case you need to mention the other columns explicitly. So this is how we cover everything. So first we saw primary key, then we covered foreign key, then we saw unique key, then we saw not null, then also we saw check constraint and default as well. And that's all for module 4, that is constraints. So understanding constraints is essential for designing a professional database that stays clean and consistent. In the next module we will go deeper into data retrieval with advanced select queries of PostgreSQL. So let's move to the next module. Hi everyone, in this module 5 we are going to learn one of the most important things in SQL, which is how to query data effectively. We will cover in this module filtering using where clause, sorting using order by, limiting results using limit and offset, removing duplicates using distinct, and using some comparison and logical operators. By the end you will be able to write clean and powerful select queries. So let's start. First we will see filtering data using where clause. So for that let me set up one example that's I'm creating one table called employees with these things, and I'm inserting some data into the table. So let me finish this one. So the table is created and 4 records are inserted. Okay, so now let's understand concepts one by one. So first we will see the where clause. Okay, so how where clause works. So this is where clause and we'll see how it works. So whenever you want to retrieve specific records instead of entire table, you use the where clause. Okay, so the syntax is also very simple. Syntax is like this. First we write select obviously, and then list of columns. It can be column 1, column 2 and so on. Okay, and then we write from, then the table name. Okay, from the table name, and then here we write where, and then we can have conditions here. Okay, so this is how where clause work, and in where clause we can have as many as possible conditions. Okay, so let's see with examples. We have already set up the data. So this is the data that we have already set up, and on that I'll try to show you some examples. So first example we can see to get all employees from IT department. If I show you data from here, it is there are 2 employees with IT department. So how I can retrieve them? Only those records. So how I write that? So I write select star from. So why I mentioned star? Because I don't want to write all the columns one by one. So star means all the columns will be selected. So select star from employees. Okay, then where condition, then the condition. So where, as I said, department should be IT department. So department is IT, and then semicolon. So what will happen? Out of 4 records, only 2 records will be returned, so with having employees with IT department. Okay, so this is how First we retrieve the selective records. Now I'll show you another example. Get employees with salary that is greater than 60,000. Okay, so how we write that? So for that also let me copy this much, so I don't need to type again and again. So I have copied this much, and then what would be my condition? My condition should be salary greater than, or also I can place equal to if it is greater than equal to, but in this case it is greater than. Okay, greater than 60,000. So this is 60,000. So let me query. So one record is written, that is David, it's having 75,000. So let me verify. So there is one employee David with having 75,000, which is more than 60,000. If I mention greater than equal to 60,000, then this record will also be included. So let me show you. So this is greater than or equal to. Okay, so here we can see that two records are written. That means we have used greater than and greater than equal to symbol as well. Okay, so this is how we filter the data. Now let's see how we sort the data. Suppose I want this record to be first, I want this record to be first, or whatever I want to see first on the basis of some columns, I can do that. So that's done using the order by keyword. Order by. So the data sorting is done using order by keyword. The order by clause helps you sort your results either ascending or descending order. So if I don't mention anything, by default it's ascending. If I have to make descending order, so I need to explicitly provide that. So let's see with examples. Now the first example is to sort employees by salary, highest one should be come first. So how I do that? Then again select star from employees, then order by, on which basis I need to do salary. Okay, so as I said, if I don't mention anything, it will be ascending. Ascending means lowest first and then greater ones, but here I am saying that the highest should be first, so I need to mention DSC, that is the descending. Okay, so let me query. So all the employees are written with, if you see the how they are arranged on the basis of salary. Highest salary, then the 60,000, then 55, then 50. Okay, so this is how the data are sorted. So let's see another example. So sorting the names alphabetically. Okay, so the sorting can be also done. Maybe say select star from employees. Okay, then order by name, and it should be alphabetical. Alphabetically means in one order it should come, like in a dictionary manner. So I leave it as it is, otherwise I can mention ASC only for ascending order. So let me query. So here if you see the Anna, it came first, then David, then John, then Sarah. So sorting makes your results much easier to understand. So you don't need to all the time to filter out the data. You can also sometimes sort the data, and also it is possible to combine them. Yes, so let me combine. Maybe say I can say this one I'll combine with order by. I'll combine the where clause. So how we do that? First we need to mention the where clause. Okay, where I can say salary is greater than equal to, I can say 55,000. Okay, so that means wherever salary is greater than equal to 55,000, take only those records, and also whatever record is written, so make them in descending order. So let me do this. Okay, so three records written as per this condition, and whatever the data is written, they are also sorted now. Okay, so this is how we can mix where clause and the sorting. So this was one more concept, and now let's see limit and offset. Okay, this is also important, limit and offset. Okay, so how it works? So limit means it restricts the number of records to be written without any where clause, or even if we have where clause, so it will limit the number of records. Okay, and offset means to skip the data. So if I mention offset 1, so it will skip first record. Okay, so offset skips some rows before showing the results. So let's understand this with example. So first example, it's like showing only first two rows of the employees table. So I can select like this, select star from employees, then I can provide limit 2. Okay, fine. So this will what it will do, it will limit the results up to 2 records. Okay, so see, so the first 2 records are returned from the employees table. So similarly, I can write using the offset. I can say skip first 2, then show the next 2. Okay, so let me copy this one. So select star from employees, then I need to mention offset and limit. So I say offset 2, then limit 2. That means out of 4 records, first 2 will be skipped, and then whatever the results come, it will be limited to 2 records only. So let me show you. So see here 3 4, what happens if I make it 1? So only one record will be returned after skipping first 2. So let me show you. So this is how limit and offset works. So limit limits the record and offset skips the records. Okay, so this is super useful when building pagination features in websites and applications. Okay, so when you build web applications, etc., and you have many records to show, so you can use limit and offsets. Okay, so now let's see data filtering using distinct. Okay, there is something called distinct to get the distinct values. So distinct does what? Distinct removes the duplicate ones. Okay, so it will remove the duplicate ones. So for example, we can have in the data, if you see, we have 2 employees with the IT department, correct? But I want one record. So for example, say if I want to see the departments, like I want to know the employees having the departments, so it will be written like IT HR, IT finance. So IT is written, it will be repeated 2 times, but I want only one time the IT should be shown in the result, only one time. So how can I do that? How I can do like this. So this is department. So how I write this? So select, then distinct, then distinct, which columns to be distinct? It is department column of employees table. So department, then as usual from employees. Okay, so this is how we can make the distinct. So here you see that we received 3 records only, but if I remove this distinct, so 4 records will be written. Okay, see, 4 records are written. So this is how distinct is useful to remove the duplicate data from your data sets. Okay, so distinct makes your results clean and unique. Now let's see some comparison operators. Comparison operators such as we'll see equal to, we have already seen equal to, so we'll see not equals to, we'll see greater than, less than, greater than equal to, and less than equal to. So let's see with examples. Okay, so first example we will see employees earning at least 60,000. Okay, so how we do that? Select star from employees. Okay, then where condition. Okay, as we said, salary should be at least 60,000. So whatever is greater than or equal to 60,000, it should work. Okay, so this was, I think, our first example. So same we are repeating here. So here we receive 2 records because there are 2 employees with having salary at least 60,000. Okay, and also we can have, there is another thing called not equals to. Okay, so I can show you an example where employees are not in HR department. So how we write that? Select star from employees, employees, and then where department is not equals to HR. Okay, so there are 2 ways to write not in. I'll show you. So apart from HR department, we have received 3 records. So this is one way, that is less than symbol, greater than symbol, and there is another way also to write, that is exclamation mark and then equals to. That means this is not equals to. Okay, so this will also give the same result. See, so there are 2 ways to do it. So whatever you prefer, you can do. Okay, so this was about like there are other operators, less than and equal to, only equal to, so you can try them with examples. So now let's move to logical operators, that is and, or, not, etc. Okay, so these help you combine multiple conditions. As I had said earlier in the where clause, we can have multiple conditions, right? So now let's see and operators. And operators returns rows only if all conditions are true. So if you remember the truth table, it would be helpful. So AND operator works on when both the conditions or all the conditions are true, or conditions work when one of the conditions is true. So same thing is here. Okay, so first we will see the AND operator, where all the records are satisfy the condition, all the conditions are satisfied for those records will be returned. So for example, let me write some queries. Select star from employees, where okay, first condition is say department equals to IT. Here I can write, and so you can write it in lowercase or uppercase, doesn't matter. So salary should be greater than 60,000. So only those records will be returned where department is IT and salary is more than 60,000. So let's see if such employees exist or not. So yes, one employee is there, David, whose department is IT and its salary is more than 60,000. So this is how we can combine data. We can combine the query using AND operator. Similarly, we can use the OR operator. In OR operator, in if one of the condition is satisfied, so that record will be written. So let me modify this one only. So maybe department equals to IT or salary is greater than 60. So if even if one condition is satisfied for the record will be returned. So let me see. So two records satisfying the condition where department is IT or salary is more than 60,000. Now we can also use same column. So for example, say department equals to IT, or I can write again department equals to HR. Okay, so this also should work. So this also works. So here you can see that only those records are written where department is IT or department is HR, not other department. Let me see what was the another department, and the department was finance. So this record was not written because it doesn't satisfy the condition. Okay, so this is how it works, and we have already seen many things. So now let's see not operator. Not operator negates a condition simply. Okay, so let me tell you the example. Select star from employees. Okay, where then not department. Okay, not department equals to maybe say IT. Okay, so that means all the records will be returned where department is not equals to IT. So this is helpful when you don't know the other departments or other values code, but you know what is the value that you need to exclude. Okay, so this is basically to work on excluding the data, that is the not operator. So in this module we covered where clause, order by, limit and offset, distinct, then some comparison operators, then some logical operators using and, or, not, etc. If you find this helpful, hit the like button and subscribe for more PostgreSQL tutorials. So in the next module we will dive into more advanced querying techniques. So let's move to the next module. Hello everyone, in this module we are going to learn one of the most important concepts in SQL, joins. Joins allow you to combine data from multiple tables, and without joins, RDB, that is relational databases, don't make much sense. By the end of this session, you will be able to confidently write inner joins, left joins, right joins and full joins. So let's begin. So here I have prepared one data set for practice and setup. I have provided this with the link. So just copy here, and also you can just select everything and execute it. So this should be executed like this. So the data is set up. So you can refresh and you can see here. So the tables are created, and within the tables we have data. Okay. So now let me clear these things from here. So first we will see what is join. Okay, so a join is used when you need to read data from two or more tables based on some related columns. In our practice dataset, employees belong to departments. That is, employees.department ID equals to departments.department ID. So this shared column is what we use in join conditions. Okay, so let's understand join conditions. Join conditions usually looks like this. We can write like this, maybe say on keyword, and then we can write like this on, as we said, employees dot department ID equals to then departments departments dot department id. Okay, so this is how we write joins. So this tells PostgreSQL how to combine two tables or how two tables are related to each other. Okay, so now let's see first the simple one, that is the inner join. Okay, how inner join works. So inner join returns the matching rows that exist in both the tables. Okay, so the use cases can be to show each employee along with their department name. Okay, so how we write that, we need to, if you see in the data that we had created, let me write like this: select star from employees. Okay, so if I select the data from employees, here if you see there is no department name, rather we have department id, but from the department id we are not sure that what this 1 2 3 etc means. So we want one such SQL where we can have the employee name, employee age, salary, etc., and also the department name, not the department ID. So we need to join that thing with department table, because we know that department ID is the key that is related to department and employee. How we write that query? So this is very important, writing the query to join the tables. So first select keyword and then the columns we can have, so we'll fill them later. So as of now let me put only star here, and then from which table we are going to write these things. So employees. So for there is something called alias to make it simpler. So I'll explain you later these things, but there is something called alias, that alias name, or you can say one short name. Okay, one nickname you can give to a bigger table, so you don't need to type employees departments again and again, so you can write one short things. And it will be join, how it will be join? Inner join. Okay, inner join to what? Inner join to departments table. Okay, and to departments table I can give one alias name department. Okay, how we use alias name we'll see now. Okay, so it is joined. Now comes the on keyword. On what it will be joined? As we said here, it will be joined on the department id. This one we can join, so I can, instead of writing employees, since I have renamed it to emp, and this is also dept. Okay, so now we have joined the tables. Now we want records on the basis of data. Okay, so now I want emp dot, what I need, employee name. So emp dot employee name, comma, the next column should be maybe say what it can be, it can be department, that is dept, department dot department name, and we can say emp dot age, etc. we can return. Okay, so if I write this query, so all the records will be written, but one thing you will see here, this record for JIF, it will not be returned. Why it will not be returned, we'll see in some time. Okay, but you will see 9 records will be returned. So let's query this. Here's the output. So here you can see that we have 9 employees record and along with their department names. This is how inner join works, and there are obviously complex inner joins as well, so we'll see them later. Okay, so this was all about inner joins. So as I have already explained you, only employees who have a matching department shows up. Okay, since every employees in our data set has a department, all records appear except the one that was not having the department. Okay, that department was blank. So this was all about the inner join. Now let's see another one, that is called left join. Okay, left join or left outer join we can say. So the purpose of left join is to return all the records from the left hand side table even if no match exists on the right table. Okay, now you might be thinking that this would be the case that I need all the 10 employees. Okay, not the 9 employees, but the department, corresponding department should be blank, but that record should be returned. Okay, in that case left join is useful. Okay, so the use cases is to show all the employees and their departments if they exist, and even if they doesn't exist, so still I should be able to get the employee details at least. Okay, so I'll say, copy this much, and again I can modify this. So this, the syntax is same, but only one thing is that instead of writing the inner, I need to mention it like left. If I mention left join, what will happen? So all the left means, so this is the left table and this is the right table. Why this? If you write like this, so it is better understandable. So if I mention here left join, so left table will be returned with all the records and right table is optional. If the record is present on the basis of this match, it will be written, otherwise they will be blank values. Okay, so if I query and show the output, you will be clear. So here it is. So now you can see that all the 10 records are returned, okay, except for JI. It is department is null because the JI's department doesn't exist in this, because we have a null value for the department ID in employees table for JI. So this is how the left join works. It is useful when data might be missing on right hand side table. So similarly, there is one more thing called right join. Okay, so this is exactly opposite of this one. So if I say that I need all the departments information even if corresponding employees are not present, that means there are some department where department is present but no employees are working with that department, so that should also be returned. So again, as I did, so I'll copy this much, let me paste here. Okay, so only what I need to change here, it is to make it right. Okay, so that means all the data from the right hand side table will be returned even if there is no data in the employee table, that means blank. Okay, there is no matching data in the employees table. So let me query this. We have got the right outer join result. So in this right outer join result, if you see that on the basis of department, what we did, we have department, if a department is having 0 records, it will still be appearing with the null employees value, but in our dataset there is no such scenarios, hence we have returned everything. Means everything means all the records of department are returned. So that means whatever the department we have created, that's having at least one employees. Okay, so this is how right join works. So now let's see full join. So there is one more join which is called full join. So full join is combination of right join and left join. So again I'll paste the same thing, and instead of writing here left or right, I can make it full join. Okay, so full join shows all the employees and departments, even unmatched ones. Okay, so let me query this one. So here we can see that we have got all the results. Okay, so J, null and age, etc. So everything is written from the full join. Okay, so this combines the effect of left join and also right join. This is useful for data comparison and audit purposes. Okay, so these were the main joins, and there is one more thing that is called cross join. Okay, so cross join is something like we say cross product, that means cross product, that means if there is 2 cross 3, so we know the output should be 6. Okay, so this is how exactly it works. If in one table there are 2 records and on the second table there are 3 records, so total 6 records will be written, that means 2 cross 3, that is 6. Okay, so this is how cross join works. So how it works, so for cross join we don't need to mention any condition, joining condition. If we omit this one and we just make it cross join, so it will be done automatically, but this is not useful. But if we want to see all the possibilities, okay, then we can do this. So that means omitting the on condition, that means the joining condition. So let's see. Okay, so I need to mention here cross, not the full. So if I query this, let's see output. So here we see 40 records written. Okay, so that means there are 10 records in our employees and then 4 records with the department. So that's why we have received here 40 records. Okay, so you can verify this. Some more practical joins with examples. That is the first one that we can see, to list employees with their project roles. Okay, so how we write this, so select and then I leave it star and then from say employees. Okay, I'll give one alias name, that is emp, and I'll make one inner join. Okay, so why inner join? Because these are more practical ones. So inner join and inner join employee project, that we have that table employee project, we can see ep for example, and we can join it emp dot employee id equals to ep dot employee id. Okay, so these are the two columns that are common between the two tables, employees and employee project. So and also I can join another table, inner join, I can say project because I want to see the projects, that I can see proj in short, and then ep dot project id equals to then project dot project id. So this is how the data are related. Now I'll select here that what columns need to be shown. So for example, say I can select employee name, so emp dot employee name I can select project dot project name, and then I can also select maybe say ep dot role, that is role description. Okay, so this way we can write some more realistic and complex joins. Okay, so here I have missed the keyword on, so that's why it was giving error. So now let's do it again. Okay, I have missed something else as well. Okay, so this is employee projects, not project. So now let's query. So this is how we have received the result. So we have 8 employees that are working. Why 8 employees? Because we have made the inner join, so those 2 employees having no projects, so they were not included in this result. So now let's see another one, that is to count the employees per department. So we can have here left join. Okay, so because we need to count the employees for each department. So let's see. So it can be select, then I'll leave this one as it is, then I can write like this, from departments. Okay, let me do it only D departments, then left join what, left join employees, so E, and it will be joined on the basis of D dot department ID equals to E dot department ID. So since we need to count the employees, so what I'll do, I'll write like this, D dot department name and comma the count. So count, what to be count E dot employee ID I can say, or employee name, so whatever it works. So I can give an alias name as counts. Okay, so employee counts. So since I have mentioned here count, so I need to mention the group by. Why I am mentioning group by? So when I cover the group by having clause etc, I'll explain there. Okay, so department name. Okay, so let me write this query and execute. So this is how we got the output. So that means in marketing department there are 2 employees, finance 2, engineering 3 and HR 2. So these are total 3 to 5 to 7 to 9. Okay, so there are 9 employees with having department, and we know J is having no department. Okay, so this is how we count the departments. Let's see one more simple example to show the department even if they have no projects. Okay, so how we do that? So we need to see like this, select, I leave this one with star, later I'll change. Okay, from departments, say D. Okay, then left join project, that is P. So on what it will be joined, it will be joined on department ID, D dot department ID equals to P dot department ID. Okay, so this is how we join. And also, so what need to be shown here, that is D dot department name comma, here I can have P dot project name. Okay, so let me query this much. So here it is. Okay, so we have these 5 departments with these records. Okay, so this is how we did this. So we have covered the join conditions, we saw how to join, how join condition works, we have covered inner joins, left join, right join, full join, cross join also, and we saw some examples. So let's go to the next module. Hi everyone, in this module we are going to cover most powerful parts of SQL, that is functions and expressions. So these are tools that transform raw data into meaningful and usable insights. So first we will cover some string functions. Okay, so these functions are essentials when working with names, text fields or any character data. Okay, so in string functions there are some functions we will cover. So first we will see string functions, and first function that we are going to see is upper and lower. Okay, upper and lower function. So what do they do? So upper function converts the text into uppercase and lower function converts the text into lowercase. So for example, we have employee table and employee data, so on that we'll build our examples. So I'll write select emp name. Okay, so the name of employee, and I'll check again the names in lowercase, so I can make all the characters in lowercase. So this is how we can write, and also I can make it upper, so upper emp name and from employees. Okay, so now we'll see the output. Okay, so search path was set and now we can see the output. So here in the output we can see that we have the names of employees as usual. This is the normal name. Here we have made them all in lowercase and then we made them all in uppercase. So this is how upper and lowercase works. And there is another function called length function. Okay, so length function gives the length of a string. So let me take this example and I'll edit this. So for example, here I can add one more function, that is length. Okay, so length of a string it will provide, so emp name. So what is the length of each employee name we can have here. So here's the output. So here we can see that we have got the length of all the employees name that we have. So whatever, for example, for Bob this is 3 characters, so the length is 3. So this is how length works, and this gives the number of characters that are present in a particular column or a particular string. Length function. And there is another function that is useful, that is called concat function. Okay, concat function. So concat function is used to combine two or more strings together. Okay, so this joins two or more strings. So one example we can see like this. We can make select maybe. First let me write the concat. So within concat I need to pass the strings. Okay, so the first character is employee name, and then I can write like this. So the second parameter can be works in, then this, and then the department ID. Okay, so this is the simple example, and as many comma and as many parameter we can provide here. So maybe we can write as info from employees table. So let me query this. So here is the output. So we can say that Alice works in one, Bob works in one. So they are the departments, and also we can modify them, we can edit them, we can format them better. So this is how concat function works. So this combines or concatenates multiple strings. Okay, so there is another function, very useful function, which is substring function. Okay, substring function. So what do substring function do? It extract part of a string. Okay, so for example, like I can write select emp name. So this is the name we have, then substring of that emp name. Okay, so how we write emp name. Now we need to provide, this is the column that we have provided. Now we need to provide from where to where I need. Okay, from say 1 to 3. Okay, so that means starting point is 1 and it will go up to 3 characters. Okay, so I can say as you can say short name. Okay, as short name. Okay, so this is how I can give one name, and then from employees. So let me query this. Okay, so this is not from 1 to 2, this is from 1 for not 2. Okay, so let me query again. So this is the output. So here you can see that all the names are truncated up to 3 characters only. Who had the longer names, they are truncated to only 3 characters. So this is how substrings works, okay, to extract part of string, a longer string. Now let's see another function, that is the replace function. So this is also very useful function, replace function. So this replace text inside strings, okay. So we'll take the same example and modify. Let me change into this. So this is replace, okay. So in the emp name, what to replace? So wherever there is a, okay, so wherever there is a, I'll want to replace it with I can replace it with the asterisk. The first parameter is the string or column, the second parameter is the searching string, that what to search, and the third one is the replacing string. So with what we are going to replace, okay. So just let me query this. So here if you see, wherever there was one this lowercase a, they are now changed, they are replaced with asterisk. So these were some useful string functions. Now let's see some mathematical functions. So mathematical functions are extremely useful when working with numeric values, say salary, age, or any numeric calculations, etc. Okay, so the first function that we are going to see is round function. Okay, so round function, this rounds numeric values. So for example, let me select data, select employee data, select emp name first, and then salary, okay, and then I can make salary divided by 12, okay. So this there is a chance, okay. First let me show you, okay, as maybe I can say monthly salary, okay, from employees, okay. So let me first query like this, okay. So here you can see that we have many decimal points, okay, but we don't need them. I want to round off them, okay. So how I can write that? So there's a round function, round, okay, and then the second parameter is up to what characters I need to round it. So maybe up to two decimal points is enough. So I will do that query. So here you can see that the data is refined, and we can see that the some data are rounded off, because we saw that it was 0.666 and so on, but it is now rounded off to 6.67. But if I round further, it should be changed. So let me query again. So here you can see that it was zero point 0.7. So after the decimal points, rounding off works. So this is how round function works. So now let's see another function, which is cell and floor. So this is also very interesting function, cell and floor function, okay. So cell function rounds up and floor functions round down, okay. So we'll see with examples. So this is the normal rounding off, but we'll use the scaling function again. So on this we'll use the scaling function. So this will make the rounding up, so that means the next whole number will be there. So seal, okay. So there is no parameter, means only one value will be there, and then floor, so it will take to the nearest lower integer, okay. So let me write like this, formatted. So now if I query, I'll get the output, okay. So here you notice that this was 5416.7, so it was rounded upwards, okay. So it was made 5417, and when I say floor, so it was rounded up downward, okay. So the nearest downward number will be taken in case of floor, and nearest whole numeric number will be taken in case of scaling function, okay. So this is how scale and floor functions work. So there is another powerful function which is called power itself, okay. So this raise number to a power, so we know that 2 to the power 3 is 8 and so on. So there is a function also to do that, okay. So for example, I can write like this, select I can say power, first parameter is 2, second parameter is 2 raised to the power, okay. So I can select this much, So we got 8. So this is how power function works. So we can change it 3 to the power, we can say 5, so we can say the output, so and so on. So this is how power function works. So there is another function which is called absolute function. Okay, ABS, absolute value. So it provides as its name suggests, it provides absolute value. So even if we provide any negative number, so this provides absolute value. Say I provided -50 and then I apply the absolute on -50, so we'll get one as negative and one as positive. So see, so this was only -50, but when I applied the absolute, so it made as 50. Okay, so your task is to identify the absolute value of 0. Okay, so what absolute value of 0 will be provided. So this was all about some mathematical functions that we covered. Now let's see some date and time functions, which is very important in PostgreSQL. So date and time functions. Okay, so date and time functions we'll use quite frequently going forward, so they are very important. Okay, so now let's see current date and current time functions. Okay, so how they work, they are simple. Select current date, so this will provide current date, and current time, so this will provide the current time. So let's see. So here is the output. So what we can see here, so this is the current date, that is 2026 4th sorry, April and 28th, so 28th April of 2026, and this is the time 9:38:47 am, and this is the time zone. So this basically gives the time with time zone, and this gives the date value. So if I query again, so obviously this time must have changed. So let me see. So this time is changed, so this gives the current system time. Now let's see age function. So there is something called age function. So this is the differences between two dates. Okay, it provides the aging of two dates. So for that, let me write like this: select emp name from employee and age function. So within that I'll have parameters. So this is the current date, okay, the starting point, and then the point in, we can say, like a date I can take, and in date let me say 2020 0101, sorry, 0101. So I want to have the differences between these things. Okay, as maybe I can say as experience I can add. Okay, so if you have two dates, you just need to pass the date. So I don't have any date values in my employees table, so that's why I need to mention a date like this. So I can query from employees. Okay, so let me query this. So this will give me the age values for each employee. So here's the output. So obviously it will give the same date, because uh, I am differencing because I'm differentiating because I'm calculating the age between the same numbers. Okay, that's the current date, this is the same for all employees, and this date is same for all employees. So your task is to add another column into the employees table, which can be hire date or which can be birth date, and then you can calculate the age properly, age of employees. Okay, so now let's move to the next function. This is the now function. This one we have already seen while talking about the default values. Okay, so we know now functions give the current time and date, everything. So select, this is very simple to write now. Okay, so we saw that there is a function called current date and current timestamp. So now is the mix of both things. So this will provide your current date and also time with time zone. Okay, so the data type is also timestamp with time zone. So this is how now function works. So if I execute it again, so this will give me new value, again new value. So this is how now function works. So this is also very important to capture the current timestamp, because this captures time with timestamp. Okay, so there is another useful function which is called extract function. Okay, so it extracts the date parts. Okay, so whichever date parts I want, I can extract. Okay, so for example, I can say select, and then I can say extract extract, I can extract say year from current date. Okay, so this should extract the current year from the current date, that is 2026. So here is the output. So this is how we can extract part. Let me try to extract month. So let's see. So this extracted the current month, that is the 4th, that means April. So this is how extract function work. So these were some very useful date and time functions. So now let's move forward with conditional expressions, that is case when. So let's see case when with some examples. So the first example is to categorize employees based on salary. Okay, so I can have a requirement that if one employee is having salary in this range, he will be highly paid salaried employee, and if the salary range is less, so that means underpaid employee, and so on. So I can have that kind of data as well using case when. So let me write select. First I will take employee name, then the salary of employee, then case. Okay, case, how we write. So this is how we write. Let me make it clear. So okay, case when. So what's the condition? So when salary is greater than 60,000, okay, then we can say high. Okay, when salary between also we can use, okay, or greater than equal to, and then add another condition, okay, that also works. And between we can say 59,999 and so this should be the lower range 55,000, okay, and the higher range is 59,999. Okay, so then I can say medium, then medium. And just like if else, we can have the else block. So here is else we can mention that is low. Okay, so this is the end, and we end of the case expression, and we can give the alias name to it, that is salary range, okay, from employees. So let's see if it works or not. So here it is. So this works. Okay, so because as per our condition, where salary is 65,000, so this is high, this is also high, and this is low because this is 48,000, which comes neither in this range nor in this range. Okay, for medium, say this one. Okay, this is medium because this comes between this range. So this is how we can use the case expressions. Okay, so this was one example. Okay, now let's see some examples combining all these kinds of functions that we saw individually. So first example, we will see like how I can create one professional employee description. Okay, so for that I'll write select first, and obviously from employees. Okay, sorry, employees. Okay, now I need to write the columns. So first what we'll do, I'll take the employee name. Okay, employee name data I want to modify, so employee name I have taken, and then what I'll do on employee name, maybe I can do it upper first. Okay, so I made it upper first, the upper function I used, and then I can concatenate it with using concat operator. Okay, so let me say concat, okay, the upper name and then concat, and then the parameter I can provide. So in the parameter I can have like this. Okay, so the name and then the pipeline will be appear, and then the department. Okay, so the department will be like this department, and then I can write like this department ID. So as we know that as many possible parameters we can provide into this, and then again pipeline, okay, to separate the data, and this much. Okay, so this is how we can write. And also in the concatenate we can have one more thing, that is the current year. Okay, so how we can write, extract, we can also write like this, maybe year, okay, sorry, year, at what year the data is extracted. So it can be like this: extract, then within the extract we know what to extract: year from current date. Okay, so this is how we combined the upper lower function. We have used concatenate operator and we have used extract functions. So let's see, this is the, I can give one name to it. Maybe I can write summary. Okay, so this is one alias name. So let me query, it should work. Okay, so here you see, so for Bob maybe, so this is the name, this is the department one, and this is the current year is 2026. So for all the employees we have written like this. So you can modify this and you can add more things. Obviously they are possible, so you can try and do some exercises. Okay, so there is another example also around mathematical functions to calculate tax and salary, etc. So let me write like this: select first from employees. Okay, so within that I can add some column. So yes, employee name first, and then salary, and then I can write salary multiplied by 0.10 as I can say tax. So that means the 10% of salary is tax. So I can have the net salary. Okay, because the tax portion is the deducting portion. Okay, so that will be deducted. So salary minus the tax part. So this is the tax part. I can copy and write. So let me write like here. Okay, so this is, I can say, net salary. Okay, so and also in the net salary, what we know, we can round it. Okay, so let me perform the rounding off. So this is rounding off of 2, maybe you can say 2, and also here I can round it, rounding off up to 2. Okay, so let me query. So this is the output. Okay, so this is the salary value, so this is the tax portion. If we do minus, so this is the output. So this is the net salary. So this is how we used some mathematical functions as well. So this completes the module 7, that is functions and expressions. So these functions are incredibly powerful, and they are very useful for calculating purposes in business metrics, build logics inside the queries, etc. In the next module we move into grouping, aggregations and analytics, etc. So they are very useful and they are very powerful things in SQL. So let's move forward to the next module. Hello everyone, in this module, that is module 8, aggregations and grouping, we are going to learn about summarizing data, calculating totals, averages, counts, and how to group records meaningfully. Okay, so this is one of the most important parts of SQL used in analytics, reporting, dashboards, and backend systems. So let's get started. So what are aggregate functions? Okay, first we'll see aggregate functions. So they allow us to perform calculations on multiple records at once and return one single result. Okay, so for example, we can have like common aggregations functions such as we have count. Okay, and we have sum, we have average, we have mean, we have max, etc. Okay, so these are some aggregation functions. So now let's see all of them with examples. Okay, so first we'll see the count function. So this is useful for counting the records. Okay, so for example, I want to see how many records are present in a table or on the basis of criteria. So this is very useful. So I can write like this: select count star. So that means to count all, and as total employees from employees table. Okay, so let me see. So there are 10 employees in the employees table, and also what will happen if I write where department id equals to 2. So this will count all the employees where they are working in the department id 2. So let me see. So there are 2 employees. Okay, so for department 1 there are 3 employees. So this is how it works. Other functions, mean and max function. So that means mean is for minimum value and max is for maximum value. So we can write like this, select, we can write select mean salary. Okay, so this is the mean salary, so the minimum salary of the result set will be written, and this is the max salary. Okay, the maximum salary of the results will be written from employees. So in this query basically I will see the employees having the minimum salary and the maximum salary. So minimum salary is 46,000 and maximum salary is 90,000. And also here I can introduce the conditions like where clause. So let me write this, where department ID 1. So now the mean salary and max salary will be calculated on the basis of department ID 1. Okay, so let's see. So that means it says in the department ID 1 the minimum salary is this and maximum salary is this. Similarly I can change it to, maybe I can make it department ID 3. Okay, so this is the department ID 3 data. So in the department ID 3 this is the minimum salary and this is the maximum salary. So the mean and max works on the basis of the result set that is generated from here. Okay, so this is just the formatting of the data. So this is how mean and max salary works. Now let's see the sum. So sum means the summation, so we can make totals. Okay, so similarly we can write like this, sum of salary. Okay, we can do like this, sum of salary from employees. Okay, so this is possible. So I want to see basically what is the expense of the company towards employee. So this is how much we pay to all employees as sum. So again I can have some conditions here, that if I put where clause, so the data will be further filtered. So let me query. See, so for the department ID 3 this is the amount, and for say department ID 1, so we'll get another output. So this is the total sum. Okay, so this is how sum function works. Now let's see another function which is called average function. So this is also very important function and very useful one. So average function, obviously as name suggests, it will give you the average value. So for example, say select, here I can say average. Here I'm not taking salary. Here let me say I'll take the age. Okay, select average age from employees. So I want to see the average age of all the employees. So this is how it works. So average age is 30.5. Again here I can add conditions where department ID 1, for them only I want to see. Why I'm adding these things, so in some time I'll let you know when I go to the grouping. Okay, so now let's see for department ID 2. Now let's see grouping. So why group by or grouping is very important in our case or in our work. So aggregate functions alone summarize all records. Okay, so just like here, if I want to say for department ID 1, I want to write again and change query for this, and again if there is something I need to change. So this is how aggregates work, but I want to see for all the employees and all the department. So in that case group by is helpful. So but what if you want the total per department or the average salary per team? So that's where group by comes in. Okay, so we'll see with example. So for example, say we want to calculate the number of employees per department. Okay, so first we can write like this, select, we have seen the count function. So from employees we know, okay, this will give 10, we know. Okay, but I want to see for all the department. So here we need to provide department ID. Since we have provided here department ID, we need to have this column in the group by. So apart from the aggregate functions, whatever we introduce in the select list, we need to add them into the group by, otherwise it will give error. So let's see. So this gives error, okay, because department ID must appear in the group by clause, but we haven't provided it. So let me write like this, group by department ID. So now this should work. So let me query. So this is the result. Now it says that count is 1 for null. So that means for null department, that means there is one such employee with having no department, and we know it's J. Okay, so for 2, that means there are 2 employees in department ID 3, there are 3 employees in department ID 1, and so on. So this is how we do. And also, if I want to see this kind of thing that we were doing for average salary and average age, etc. So again we can write like this: department ID, and we don't need to change the where clause again and again. We can omit that, and we can write group by department ID. Okay, so let me query. So at once we got all the such results. That means for all the department, what is the average age? So that means for department 3, this is the average age, department 2, this is the average age, and so on. So this is how grouping is very useful. Okay, so there is another thing that is having clause. Okay, so alone grouping is not useful that much, but we have one more thing that is called having functions. So this is very important to remember for you, that is where clause filter the records. Okay, group by group the records, but having filters the group. Okay, so there is, like, we can say where one, it filters the records. Okay, we'll see with examples obviously. Then group by does the aggregations, means does the grouping, and then having filters the group by. Okay, so let's say with examples. So I want to see I want to see the employees count, or we can say I want to see the employees count where there are more than 2 employees in that department. Okay, how we can do? Select count star. Okay, first let me start from the beginning. Select star from employees. Okay, so this gives all the record we know. Okay, so all 10 records are returned. Now I want to limit the record. Maybe I can say where department ID is not null. Okay, so I want to have only such records where department ID is present. So what I did, department ID is not null, I have written. So this is how null checks are done. So if I query this, automatically 9 records will be returned. 9 records are returned. So this is how where clause filtered the data. And now we'll go to the aggregations, count star. Okay, so what to count on the basis of department ID. Okay, now since I have added the department ID here, I need to have the group by department ID. So I am basically having the counts with on the basis of department ID. So let's see, as we have already seen. So this is how comes. But instead of getting all the records, what I want only that department data where at least more than 2 employees work. Okay, so how I can write that? So for that I need to introduce having clause. So having count star more than 2. Okay, so this should return only one record, this one. Okay, because count more than 2 satisfy for this one only. So let me query. So here it is. So this is how it works. So we can have this having clause on any other situation, like we can have having average age is greater than this, or having maximum salary greater than this, etc. So they also work. Okay, so basically having filters the group by record. Okay, if we do group by, we'll get all the information for the group by, and if we apply having on that, so again filtering of the data will happen. So this is why having clause is very important. Okay, so now let's see one common example with multiple aggregations. Okay, so let's see how I do that in one single query. I need to calculate the multiple summaries for the employees. So let me write like this: select first star from employees. Okay, and here I'm introducing the join because we have already seen join. So join. Okay, join department departments, DEPT on we know DEPT dot department id equals to emp dot department id. Okay, so we know what they are, so I'm not explaining again. Okay, so let me take here dpt dot department name. Okay, so why I'm not taking employee name? Because I don't need employee data, I need department wise data, so that's why I have joined the departments. So this is done. Now count star, what we can say, count star as total employees, we can say like this. So how many employees are there, we can have the data as total employees, and we can also say the minimum salary. Okay, so this is the main salary, and also we can see max salary, so that's max sal. And then we can also have average salary, average salary, that is average sal. Okay, you can give any name to this alias names. Okay, so we have done like this, and since we have mentioned here the department name separately, so we need to put this department name in the group by. Okay, otherwise it will give error. So let me put group by dpt dot department name. Okay, so let me query. So this is the output. So in the marketing department there are two employees, minimum salary is this, maximum is this, and average is this. So and this is how for all the departments. So this is how we can build complex summary or reports etc using these functions, aggregations, group by, having etc. So here also, for example, we can say having, we can do further filtering of data. Having, we can say um, average salary. Okay, average salary, say it should be greater than, we can say how much, greater than say 50,000. Okay, so if we do this, so this record should be omitted because this is average salary is having less than 50,000. So let's query and see. See, so HR department data is removed because that doesn't satisfy the this having clause condition. So this was all about group by, having etc. Okay, so that we have done, and also we have seen multiple columns, aggregations etc. Okay, now let's see grouping on multiple columns along with order by as well. So this is also very important. So let's see another example. This will be simpler one. So for example, I want to write like this. So select, maybe say select star from employees. Okay, so what I need to select is maybe say department id. Okay, department id, and then I can select age, and then count star. Okay, count star I have done. And on the, so since there are two columns, I need to provide them in the group by, because we know that on the basis of this aggregations, whatever other columns which are not aggregate functions, we have to mention them in the group by. Okay, so group by this. So here you can see that these all were the aggregate functions apart from this. So that's why we had to provide them that department name in the group by clause, otherwise it would give error. Okay, so here we have done this, and now let me do the order by. And also this is very important, I cannot order by something which is not in this select list. Okay, so first let me do the correct one. So department id and age, and I can change this ascending, descending etc, but let me keep it as simple. So let me query. So this is the output. Okay, and if you see the output, it is sorted on the basis of department and age. Okay, if the department is same, then it checks the age 28, 32, 33, then it goes to the next. Okay, so the department is same, so on the basis of age it will be sorted. So this is the ascending order, we can change it to descending order, so we can have the similar result. So for the department ID 1, so there are 3 employees and they are sorted in descending order. So this is how things work, okay, with group by and order by. And also what will happen if there is no such column and I want to do sorting on the basis of that. Maybe say salary is not in our select list here, but I want to order by on the basis of salary. Should it allow or not? No, it will not allow. So let's see, it gives error because salary is not here. Okay, so this is how it works. And also if I mention salary here, I need to provide the salary in group by as well. So you need to remember these things. So this was all about aggregations and grouping in PostgreSQL. And also we have seen some common errors that usually people do. So having clause is used for grouping the data, you should remember, and where clause is to filter the data. Okay, so this is all about this module that we are going to end. So in this module we have covered the aggregate functions, group by, having, aggregations with joins, multi-column grouping, and some practical examples. So in the next module we'll go deeper into the advanced SQL and we'll see subqueries in PostgreSQL. So this is very important topic. So let's move to the next module. Hi everyone. In this module we are going to learn one of the most powerful features of SQL, that is subqueries. Subqueries allow your SQL statements to think. They let PostgreSQL answer questions based on the results of other questions, means other queries. So making your queries more intelligent and flexible. So in this module we'll cover scalar subqueries, subqueries in the where clause, in and not in subqueries, exist and not exist, real examples using our employee dataset. So let's get started. So what is subquery? A subquery is simply a query inside another query. Okay, so this is simple. PostgreSQL executes the inner query first, uses its result, and then runs the outer query. Okay, so we'll see subqueries in select statement, subqueries in from clause, where clause, exist conditions, and so on. So let's see first the simple one, that's the scalar subqueries. Okay, first we'll see scalar subqueries, that is scalar subqueries. So let's see with examples. A scalar subqueries return exactly one value, that is one field. So it is commonly used in select list, comparisons, in where clause, order by, etc. So we'll see with examples. So for example, to show each employee along with the average salary of all employees. Okay, so in the grouping and etc we saw that it will give the aggregations etc, but it will not give the information of employees. But what we want the employee salary as well, and also the average salary of the employees table. So how do we do that? So select first, let me say employee name, then the salary of employee, and then I want the average salary of the employee should also become. Okay, so this is the employee data. Now what I need to do is, in the select list I need to add a subquery. Okay, that is the query inside the query. Okay, so select, what I need to do is I want to see average salary. This is average salary from employees. Okay, so we can have other conditions here as well. So we can see average sal. So let's query this. So this is the output. This query, select average salary from employees, will be evaluated for each record. Okay, so for example, so when evaluating the record for this one, again this query will be executed and the average salary calculated like this. So we can have other columns, expressions, other calculations as well. So this is how subqueries work. So this is the subquery. Okay, so within a query, within this main query, we have written a subquery in the select statement. Okay, so this was one simplest example. So now let's see another example to show employees earning above the average salary. Okay, so again we'll do like this. So first we'll take the employee things, employee name, salary of employee, etc, and also from employees. So here question is to show only such employee where the salary is more than average. So here we need to write like this, where salary is more than the average salary. Again this comes. Okay, so I can copy this and paste. So this is the same thing. So here we have written like this. So all the employees will be written where whose employees salary is more than the average salary of the all the employees. So let's see. So there are 5 such employees who are earning more than the average salary, because average salary were around 63,000. Okay, so that's why we have got these 5 records. So this is how subqueries work. Okay, scalar subqueries returns one single number compared with each employee's salary. Okay, so it's clear. Now let's see the subqueries in where clause. Okay, so subqueries in where clause. So how we do that? So this subqueries return a list of values or a set of records, and the outer query uses from the filtering. Okay, so I'll show you with examples, you will understand better. So let me form a query and example. So for example, say employees who work in departments with salaries above 80,000. Okay, so let me write like this: select first employee name, salary of employee as usual from employees. Okay, then where department id should be, okay, the department id should be here. I need to write a subquery. Okay, so this is how subqueries work in the where clause. So select department id from employees, okay, where salary is equal to, then again one more subqueries, select max salary. Okay, max salary from employees. So what does that mean? That means I want such employees records, okay, who works in that department, whose department salary is the maximum salary from the all the employees. So the first execution will be this innermost subqueries. Okay, so this will be executed, this will take the maximum salary of all the employees. So the maximum salary again will be compared with the employees, and it will take the department id. Okay, so this department id will be compared here with this department id. That's the main query, that's the outer query. Okay, so as earlier I said, the innermost query got executed first, and then the second inner query, and then the outermost query is executed. So let's see, this is the output. Okay, so here one comma was there. Okay, so let me execute it again. So this is the output. So that means Ivan and Fiona, they belong to the highest paying department. Okay, and if we want to know the department, what is the department, so we can mention department id as well. So let's see, so it's department id 3. So that means the employee having the highest salary belongs to department id 3. Okay, so this is the meaning of writing this one. Okay, and also we can have in and not in subqueries. Okay, we can use in when the subquery returns multiple records. For example, in this case, for example, say there are 2 employees who are earning maximum salary. So for example, you can say there are 2 employees belonging to two departments, department 3 and department 2 maybe. So they both are earning 90,000, and 90,000 is the highest salary, the maximum salary. So what would happen? So this record will give the result 90,000. Okay, so the salary will be compared with 90,000, and department id will be selected, two department ids, that is 2 and 3, because this satisfies the condition. And when we compare department id with the equals operator, so this will give error, because it is the equal operator always expect one single value against it, not multiple ones. So for that, how we do manage, we manage it with in clause. Okay, in, or we can also use the not in. So for example, we will see employees working in departments located in finance or marketing. Okay, so how we do that? Select, then again I can write here star, because I need all the information from employees. Okay, where department id, first I'll show you with the equal clause. Okay, how it gives error, you will be able to understand now. Okay, equal, and as usual I write subquery, select department id from departments, okay, where department name in, we can write in finance, or it can be maybe it can be HR as well. Okay, so this inner query gives me two records. Okay, I'll see department ID 2 and department ID 3. So when it's compared with one equal operator, it will give error. So let's see. So this gives error. So what's the error? More than one row written by a subquery used an expression. So here I need to change it to in clause. Okay, so now let's see, it should work. So it worked. Okay, so this is how we use the in. And also what will happen if I want to see all the employees, they're not in this department, they're not in this department. So here I can put not in here and query, the same result will be returned, or I'll make it in and here I'll put the not in. Okay, so that means anyhow I need to exclude those departments. Okay, so let me see. So the same result. Okay, so this is how in and not in works with the subqueries. And also I can have one more interesting example, that I want to see employees not assigned to any project. This one probably we did with the outer joins, left outer joins, etc. But with subqueries also we can do. So maybe say select star from employees. Okay, where employee ID not in, I can select such employee ID, select employee ID from employee projects. Okay, so what it will do, first it will filter the employee ID from the employee projects. Okay, if I show you, so these are the 8 records that are filtered. Okay, now it will check not in. Okay, so employee ID must not in these things. Okay, so apart from this employee ID we will get the record. So you can see that 1 2 3 etc are there. So in the output there is no 1 2 3 etc IDs, because so that's why we know that these employees are not assigned to any project yet. Okay, so this is how subqueries work, in and not in. So there's one more thing called exist and not exist. Okay, this is also similar to in and not in, but this is um, enhanced version of this, exist and not exist. Okay, so let's see with example. So exist checks whether a subquery returns at least one record, so it is faster. Okay, so it is faster for correlated subqueries. Okay, in our example we'll see employees who are assigned to at least one project. So here we saw that employees are not assigned, but here we want to see such employees who are assigned to at least one project. So how we can do that? Select star employees. Okay, where exist, let me make it emp, where exist. Okay, select one, here we can say select one, select x, etc. So whatever suits you. Okay, we just need to have one record. Okay, select one, usually we write select one from employee projects. Okay, maybe ep we can say, and where condition, where ep.emp id equals to emp dot employee id. Okay, so let me show you the output and then I'll explain what it does. So this is the output. Okay, so how it works, so for example say when comparing for employees, so first we started with employee id 1. Okay, and then we took employee id 1 and we are searching into the employee projects if employee id 1 works or not. So we keep searching one by one and so on. So for example say in the record number 5 we saw employee id 1 exists, so immediately we say yes, there's employee and we don't need to further checks for remaining records. Okay, otherwise if we put the in clause, it will go and search for all the records. Okay, then brings the truth value, but where we need only truth value, we need checks if exist or not exist. We don't need to see what the data are there, we just need the check. So in that case we can write like this, and also we can modify this to not exist. So what will happen? So employee id who are not existing in this employee projects, they will be returned. So this is same as writing here as we have done using the not in, but the difference I have already explained. So let me show you. So this is the output. So we know these are the three employees who are not working, who are not assigned to any project yet. So this is how we can use not in, not exist, exist and in. So this is how it works. Okay, so now let's see another type of subqueries, that is correlated subquery. So this is one of the most important type of subqueries, and you will use most of the time this kind of subqueries. We have already used that kind of subqueries. Correlated subqueries means the outer query is related to the inner query. How? Here you can see that emp.employee id we are comparing. So this emp.employee id comes from the outer query. Okay, so this is how they are correlated, means outer query and inner query, they are correlated, related. So this is what we call correlated subquery. So these subqueries depend on the row currently being processed. Okay, so this is the main outer query, this is getting processed. So inner query depends on the currently processing record. So we see one example particular to correlated subquery, that is employees earning above the average salary of their department. Okay, so similar kind of example we have seen already, but let's see with correlated subquery. So select star from employees, that we can say emp. Okay, where salary is more than, select average salary. Okay, average salary from employees. So what will happen if we write this much? This will take the common global average salary and then show the employees result. Okay, that we had seen already, that people earning more than 63,000 average, so 5 employees were written. But in this case we want to show the people on the basis of their department. Okay, so we need to correlate the department id. So how we write? Where, again filtering, department id, this department id must be equals to emp dot department id. Okay, so that means for the current employee record that's getting processed, for that employee the department id will be checked and average salary will be checked. For example, say for employee id 2 there is a average salary of 50,000. Okay, so there can be multiple employees. So for example, say their employee with salary 48,000. So for the 48,000 salaried employed, when this will be processed, so average salary of that employee will be calculated to 50,000 and it will be checked against salary. So this record will be discarded because the salary is less than the department average. So what will happen when the, for example, say department id 3, the employee salary is 90,000 and the department average is 60,000. So in that case this will be returned true and that employee's record will be visible here. Okay, so this is how correlated subquery works, and most of the time this kind of subqueries we write. Okay, so let me query. So here is the output. So there are these 5 employees who are earning more than the average of their department. And also what we can do, we can, to make it more interesting, we can show the average salary. Okay, so for example, say employee name, salary, etc., and maybe say department id, and here we can write what we can write. We can write select, again the same thing we can write here. Okay, the average salary of the employee, okay, of their department, because we know the salary of the employee, but also we want to have the average salary, that is average department salary. Okay, so let me bring it here. Okay, now let's query this. So this is the output. Now, so here we can see for Bob, for example, his department average is 71,000, but his own salary is 72,000, which is more than the average. For Diana as well, their department average is 49,500, but Diana earns 51,000. So this is how it works. Okay, so this was one real world example to show you with correlated subqueries, etc. So I believe we are clear here that we went through the subqueries. In subqueries we saw scalar subqueries, subqueries in where clause, in not in subqueries, exist not exist subqueries, and more importantly correlated subqueries, and we saw all of them with some realistic examples. So this is all about this module. We end the module of subqueries here, and in the next module we will cover the topic of views in SQL. So let's move forward to the next module. Hi everyone. In this module we explore a very powerful feature of relational databases, that is views and materialized views. So views allow you to simplify complex queries, improve security, and present data in a cleaner way to users and applications. In this module we are going to cover what is a view, why we use view, how to create and use views, how to update views, what are materialized views, and when to use which kind of views. So let's start. So first question is, what is a view? A view in PostgreSQL is like a virtual table. It doesn't store data physically. Instead it stores a query, and whenever you select the data from view, PostgreSQL runs the query that is inside the view and returns the results. So you can think of it as a saved select statement. Let's see with examples. So for example, say I have one select statement like this: select emp name, and then I have salary, okay, from employees. Okay, so this is a query and this will give results. So this is the output for this query. Okay, now we can save this query in the form of a view. So how do we do that? We need to create views. Okay, so how do we create views? We'll see in some time. Okay, so but let's understand why we use a view. Okay, so views are useful in many reasons. First is simplifying complex query. If you frequently run a long join query, we can store it in a view so that it can be simplified. It improves security. You can expose only selected columns to certain users, and also you can change the name of the view that is apart from the table. And also views provides logical abstraction. Applications can query a view without caring about underlying tables changes. Whatever changes we are going to do underlying table, that doesn't matter in case of views. And views provides reusability. One view can be used across dashboards, APIs, or analytics, etc. So first, now let's create some view. Let's use this one only. So this query we had created. Now let's save this query in the form of view. So how do we create view? So this is the statement: create view, then the view name. So in the view name we can say emp data 1, okay, and then select statement, simple. So let's create the view. I need to provide as, okay, so let's create again. So the view is created. So this is how we create views. So one simple view we have created. Now we can query this. Okay, so to query this we can write select star from emp data 1. So let's see the output. The output is same. Okay, if you see, we have received 10 records and the same data, and if I query this select statement, then also we receive the same data. So this is how view is used to save the query, and in this case the query was very simple, but in many cases when you create applications and projects, so your queries might get very complex. So to save that simply, you can create a view. Now let's create another view. So this will be one simple view, that is to show employee name, department name, and salary. So this kind of thing we have done many times, so let's do it quickly. So first we write the select statement. So select, we can say emp id, and then we can say emp name, and then we can say salary, and then we can have the department name. Okay, and I need to write from the join conditions. Also I'll write employees, that is E, and then inner join departments, that is D, on the condition D dot department ID equals to E dot department ID. So this is the query. I need to save this query as view. So first let's see the output of this query. So this is the output. So now let's create the view. So how do we create the view? Create view, then view name we can give employee department, we can write as okay, and then we can create. So let's create this view. So the view is created, and now we can query this view. So how do we query? Select star from. So this is the data of the view, and also while querying the view we can also select individual columns. For example, say emp id and salary I want to see. So that is also possible, and also we can introduce where clause etc in that. So maybe I can write where employee id is greater than 5. Okay, so this kind of things also possible. It is same as the working principle is same as table. Okay, how we query group by etc. So the same things we can do on views as well. So this was one simple view example. So now let's create another view example. So in this view we create employees data with high salaries only. Okay, so first let's write the select statement, emp name salary. Okay, so this much is enough, and then employees, and then condition where we have condition salary more than maybe say 60,000. Okay, so this is also possible. So all the things in view possible what we do using query. So now let's write create view, we can say high salary, and then as. So let's create this view. So the view is created, and now we can query the view. So select star from high salary. Okay, so let's query. So this is the output. So this is how we create views and query the data from views. Okay, so now let's see how to update the data in views. We know if there is a table and we can update the data. So how we can update the data using views? So not all the views are updatable, but simple views based on only one table can be updated. So this is very important to remember. You cannot update all the views. So updatable views can be the views where only one table is involved. Okay, let's create one simple view. So I can write like this: select maybe employee name, employee id, and salary. Okay, these three columns are enough. So salary. So I have taken these three columns from employees. So let's query and see the results. So this is the result. So I can create one view, create view, I can give name, update table, view. Okay, and as. So let's create this. So the view is created. Now I want to update the data. So how I can write that? Update, then the view's name. So the same way how we update data in table, update this view, and then set. Maybe I can make salary equals to 75,000. Okay, 75,000, where employee id equals to 1. Okay, so let's see how it updates the data. So the data is updated, and now we can view the data. Select star from this view. So let's see. So for employee id 1, here is the employee id 1. Now the salary is 75,000. So this is how we create one updatable views. But if we create complex views that consisting of join, group by, distinct, aggregation, union, etc. So in that case the view will not be updatable. Okay, so this basically updates the underlying table data directly. Okay, so far we created views using only create view statement. But what if later we want to change the view? Means we want to include some other conditions, or we want to remove some column or add some column, etc. So in that case we can use this one, create or replace statement. Okay, create or replace view. Instead of writing create view only, we can write create or replace. So I'll show you with examples. So maybe we can update this one. So this one, updatable view, we can take example. So here if you see, we have only three columns: employee name, employee id, and salary. Okay, so what if I want to change this view and add new column? So in that case, let me copy this one and make changes. In that case we need to write create or replace view name as, and then I can introduce department ID as well, okay, from employees. So let's do that. So the view is created. So that means the view, existing view, we didn't need to drop that and recreate. Instead we can write create or replace. So if I query this one now, we will have 4 columns here. So here we can see that we have 4 columns. So this is how we can create views using create or replace keywords. Okay, so instead of dropping and then recreating, so it's better to use the create or replace statement. Now since we have already seen how to create the views, now let's see how to drop the views. Okay, so dropping the views is also very easy. So this is the same statement, drop view then the view name. Let's say we drop this one, updatable view. So drop view name. Okay, so the data will not be dropped, only the view will be dropped. View means the select statement only. Okay, so the underlying data is not deleted, so the view is dropped. Okay, and also how we can verify the views, if you scroll in the schema section, here at the bottom there's a section called views. So let me refresh it. So whatever views we have created, so they are stored here. Okay, you can browse data from here, you can create, drop, edit, etc. You can do from here as well. Okay, so this was about dropping views. Now let's see materialized view. So materialized view is very interesting things in SQL or PostgreSQL. Materialized views. Okay, so how we use materialized view and what they are. So a materialized view is different from a normal view because it stores data physically. This means faster reads but requires a refresh when data changes. So this is useful for dashboards, analytics and heavy reporting. As we said, in case of views, the views doesn't hold the data physically, it just hold the select statement. So whenever we execute the select statement, so the data is brought from the underlying select query. So we can say like this one, if I query this select star from high salary, so the data is not written from high salary, the data is written from using this query. Okay, so if the data changes again, if I query this one, so I'll get new records. So but in case of materialized view, the actual data is stored in the materialized view. If you see here in the PostgreSQL, there is a section for materialized view as well. So let's create some materialized view and understand the concept. It is also very easy to create the materialized view. Let me say we can create materialized view like this. Columns select, we can have department name, and we can have count of employees, we can say 8 total employees, and we can have another column such as average salary, and we can say it as average sal, and we can have then from employees e, and inner join departments d on, we know d dot department id equals to e dot department id. Okay, since here we have introduced the aggregation function, so I need to use the group by as well. So group by department name. Okay, so this much. So let me query first if this gives me correct result or not, and don't need to mention the comma here. So let me query again. So here's the output. Okay, so as of now this is the output. Let me create the materialized view. Create. So this is also very simple. So create, instead of writing create view, I need to write materialized view as materialized view, and then I need to give the name to this. I can say first mat view. Okay, so first materialized view. So let me create this one. So the materialized view is created, and when first time it is created, it will store that many records. So let me show you. Select star from, so this is the materialized view. Okay, here remember these things. In marketing there are 2 employees and the average salary is this. Finance 2 employees, this much is the average salary. Engineering is this and this. Okay, and also we can see here, let me refresh it. Here we can see that the materialized view is here, but let me change the data in the database. Okay, so let me do what, let me update the data. Maybe say update employees data I can update. Okay, set salary equals to plus maybe say 20% I want to make salary multiplied by 0.2. Okay, so the 20% of salary will be increased for all the employees. So the data are updated, 10 records are updated, but let me see if the materialized view data is updated or not. So if you see, materialized view data is not updated. Why? Because the materialized view need to be refreshed. So how we refresh the materialized view? So refreshing is here. So this is the statement how we refresh the materialized view. Refresh materialized view and then the view name. So the view name is first mat view. So let me mention this. So the view is refreshed. Now let me query it again. So here you see the salary is now changed. So this is how materialized view works. So materialized view stores data physically, and if we drop the materialized view, so the physical data that are stored in the materialized view, those will be dropped. Okay, so this is how we refresh the materialized view and we create materialized view. Now let's see when to use which one, when to use the normal view and when to use the materialized view. So we use view when we need live real-time data. Okay, so without refreshing we can have that data, and the query is not too heavy. Okay, so when the query is not too heavy means the query execution doesn't take much time, it's faster. Okay, and also the data changes frequently. If there is such query where data changes frequently and we need to have the real-time data, so in that case we prefer to use the normal views. We use materialized view when we need fast reads. Okay, so there are complex queries but we need faster results. So every time when we execute that query shouldn't go and check all the data currently resides in that and returns the result. Instead, whatever the last refresh was there, so we can have that data. Okay, and then query involving heavy joins plus aggregations, etc., in that case also we use materialized view. And in case when data doesn't need real-time accuracy, then also we use materialized view. Okay, so this was all about views and materialized views in PostgreSQL. So this brings to end of this module 10, where we saw views and materialized view. In the next module we'll cover indexes in PostgreSQL. So let's move forward to next module. Hi everyone. In this module we are going to discuss about a topic that dramatically improves database performance, that's index in PostgreSQL. If you have ever wondered why your query is running slow, or how can you make your select queries faster, or what exactly happens when you search data from the database, then this module will answer all of that in simple and practical language. So let's get started. The question is, what is an index? Okay, imagine you are reading a large textbook with thousands of pages. I'll explain with this example. So if you want to know about some topic, that is a DB rule. Okay, so you want to learn about this topic, but if you are going to search throughout the book, so it will be very time taking. So what you do, first you go to the index page and you see there where is mentioned DB rule exactly. So you go to DB rule and you see page number 42 and 66. Okay, or there can be another examples like working group, etc. These are the pages that mentioned. What you do to search a topic or search particular data, you go to index first and search there. Okay, so this is exactly how database searching also works through index. As I said, a database index works exactly the same way. Without an index, PostgreSQL must scan the entire table first to show the results. So this kind of search we call sequential scan. Okay, with an index, PostgreSQL quickly jumps to the exact location of the required records. So if we understand technically, an index is a separate data structure, usually a balanced tree or B tree can be, and there can be other type of data structure as well, that helps PostgreSQL find rows faster without scanning the entire table. Now let's understand when an index helps. Index makes queries faster when you frequently search by, where conditions, join conditions, order by, group by, looking up for foreign keys, etc. Then indexes is very useful. For example, say I can write select star from employees where employee name equals to Bob. So in that case, how searching will happen? The searching happens throughout the entire table, and then we got the result. Since the table data is itself very low, so we got the result faster. But in case there are lots of data, then this kind of search going to take very long time, and the query is remaining very slow. If employee name is indexed, so the query will be faster. If it's not indexed, then PostgreSQL going to check all the names from the table and then return the result. So now let's understand how we create index. Okay, so the dataset that we have already, so we'll use that only. So now let's see the employees table itself. So first I query the employees table to show you the data. Let me remove this much. Okay, so these are the data we have in our employee table. For example, here let's say we want to search not through ID but we want to search through the names. This is the requirement that we don't remember the employee IDs but we remember the names of the employees, and often we do searching on the basis of their name. So we need to create index on name column. So how we do that? So this is also very simple to create indexes. So let me say this is the syntax: create index, then index name we can give. So for example, say idx emp name, and I can mention the table, on which table and column we are going to create on employees, and then on employees table, what is the column? Employee name. Okay, so let me create the index. So the index is created, and also we can verify the index from here. So let me go to the table section. So this is the table, and on employees, if I expand this one, here you see indexes. Okay, so here is the index that we have created, idx employee name. So this is how we create index in PostgreSQL. Okay, so this creates a B tree index, that is the default type of index. Now searches using the employee name becomes much faster. So also there is another way to create index, that is this time we created index on only one column. So it is also possible to create index on multiple columns, that is the composite index. Let's see another example. Maybe we can create employee name and department index. Okay, we want to include department ID as well. So employee name comma department ID. Okay, this is how we can create index, that is composite index. This is useful when we often do searches using employee name and department ID. So let's create the index. So the index is created, we can refresh it and see here. So see, the another index employee name department is also created on employees table. So this is how we create single column index and multiple column index as well. So now let's see how to drop index. So dropping index is also very simple and straight. So the drop index, then the index name. So let me say I want to drop this one. Now the index is dropped. If I refresh this, I can see the index has been dropped from here. Okay, so this is how we created index and we dropped one index. Now let's understand when should you use indexes. Okay, so definitely if there is index, there can be cost. Okay, so how that affects your database, we'll see. So now let's understand when to use the indexes. Indexes are extremely useful, but they are not free. Okay, so use indexes. You should use indexes when the column is frequently used in where condition, or used in join conditions, or contains the column contains large text or numeric values, or the table has many records like thousands to millions it can be, and the column has a high selectivity, that is many unique values are there, like email can be there, phone ID can be there, or it can be your username can be there. So there, in those cases, indexes are very useful. So for example, in this case that we saw employee name, so employee name also can be one good candidate for index. And now let's see when not to use index. So indexes are not good for very small tables. Very small tables means the data are very less. Okay, in that case indexes are not preferred, and columns with very few distinct values, such as we can have one gender column where the gender can be male or female, or we can have maybe department as well, where only there are three unique departments are there. So in that case also it is not prescribed to use index, and columns that are frequently updated. So this is also very important, because when indexes are used, the operations such as insert, update, deletes are slowed down, because every time you insert something or update something or delete something, the index page is also getting refreshed again and again. So this slow downs your DML processes. Okay, so this is how indexes can be used in some place, and also we need to understand how and when to avoid creating indexes. So now let's understand how indexes affect performance. Okay, so as of now we have created index, dropped index, etc., but we haven't seen the impact. So now let's see how indexes speed up the select queries. So the queries becomes much faster, but indexes slow down the insert, update and delete, because PostgreSQL must maintain index data structure, as I have already explained. We need to be careful while using indexes, and we should not do overuse of index. Okay, we need to use indexes where they solve a real performance problem. Now let's see this with example. That dataset we have, now let's see the example. For example, we are going to have one select query, select star from employees, where we can say maybe salary is greater than. So this is the simple query, so let me query this. So this is the output we got, the time etc. From this we are not able to understand how much cost it takes. Okay, so what we do, we need to have the explain analyze, like we need to understand the query running behind this. So we write simply explain analyze. Okay, so this is how we can get the cost of the queries in PostgreSQL. So it's simple, right? Explain, analyze and then your select queries. Okay, so let me write like this and see. So these are the cost that we see here. So here if you see, it mentions it is sequence scan on employees, so this is the cost, and how many rows are returned, etc. So actual time elapsed, etc. Filter happened on this, and rows removed by filter is 3, buffer set. So everything are there, and also execution time and planning time mentioned. But now let's say we create index on salary. So let me take this one and create one index on salary, and let's see how it changes the performance. So index, how we create index, create index IDX, I can say employee salary on employees, then the column name should be salary. Okay, so let's create the index. The index is created, I can confirm that. So here is the index. So now let's again query this one. Okay, explain analyze. So also we can see the data first. So this is the output, the output will be same. Okay, the output is not going to change due to index, only the performance changes. So this is the query and this is the result. So in this case what you notice, it still goes for sequence scan on employees. The reason is simple. Why? As I already told, that if the data volume is very low, then it is better to avoid using index. So PostgreSQL itself avoids using index and it goes with the sequence scan, because the sequence scan in this case is very faster and effective way, because for only 10 records the index searching will be done, and then it switches to actual data. So that is going to take much time. Okay, instead of that, it directly search data within this was all about indexes, that how we create index and how we explain analyze the index cost, etc. So if you have a huge data set, you can see that with example, or you can add some more data into employees table and then query to understand the index impact. Maybe in later stage we can have this example again when we have lots of data. Now let's see default indexes. Okay, so default indexes, PostgreSQL automatically creates indexes for primary key, unique key constraint, foreign key in reference table. In our example, employee ID, which is serial primary key, that is itself an index. Okay, and also that employees p key that we have created, so that also goes with index, so we don't need to create the index manually. PostgreSQL itself creates one default index on primary key, unique key and foreign key in the reference table. So this is how indexes are created and used in PostgreSQL. In this module, we discussed about indexes, how they make select queries faster, how they slow down insert, update, delete operations, how we use them strategically, and how we should avoid overusing index. And B tree is the default and most commonly used index, and the indexes are ideal for where clause, join clause, order by, group by, etc. This was all about this index module, and now you understand indexes better, how they work and how to use them wisely. So now let's move to the next module, that is module number 12, where we discuss about functions and operators in PostgreSQL. Hi everyone, in this module we are going to explore about operators, functions and typecasting in PostgreSQL. So let's start with basic operators first in PostgreSQL. PostgreSQL supports several categories of operators. First we start with arithmetic operators. Arithmetic operators used for mathematical calculations. Using them we can do mathematical calculations. For example, here is the query that we have defined. So we can do 10 plus 5, 10 minus 5, 10 multiplication 5, 10 division 5 and 10 modulo division 3. So this will give the remainder and this will give the output as only division value. So let's see the output. So here is the output. So addition is 15, subtraction is 5, multiplication is 50, division is 2 and remainder is 1, because 10 modulo division 3 is 1. So this is how arithmetic operators are helpful in performing mathematical operations in PostgreSQL. Now let's see some string operators. In string operators, first we will see concatenation operator. This double pipeline is called concatenation operator. So we'll see with example. For example, say select, then in the string I can say hello, and then the double pipeline, and then I can write like this world. This will be concatenated. So let me show the output. So this is how concatenation operator works with the pipeline. And also we can see example with the data. So select, maybe say emp name, and then concatenation operator, and then I can say works in, then the department id. So double pipeline and department id. So let's query from employees. So let's query and see the output for this. So this is the output. So for all the employees we have got the result like this. Bob works in one. These are the department IDs. So this is how concatenation operator works in PostgreSQL. Now let's see some comparison operators. Comparison operators such as equal to, not equal to, or not equals to. Also we can write like this, exclamation and equal to, that's also not equals to, and this is greater than, this is less than, this is greater than equal to, and this is less than equal to. So these are some comparison operators. For example, we can compare data like this, select star from employees where salary is greater than 50,000. So this is how comparison operators work. So this is the output, and also we can combine equal to and not equals to, less than, etc. They also work. So these are some comparison operators in PostgreSQL. Now let's see some logical operators. Logical operators, there are some logical operators such as and, or, not, etc. So let's see how and works. In case of and, both conditions must be true, and in case of or, at least one condition must be true, and not, this negates the condition. So let's see one example of this. So maybe I can write like this, select star from employees where salary is greater than 50,000, and also I can mention age is less than 35. Okay, so this is how logical operators work to combine more than one conditions. So this is the output, and also I can say, like, I can also write like this, in place of and I can make or, I can make age is greater than 50. Okay, so whatever conditions satisfy, the record should be written. Okay, so in this case we have got 10 records, so because at least one condition is satisfying for this criteria. Okay, so this is how logical operators work. And now let's see some special operators such as in, between, like operator, etc. So they are there. And in case of in, it helps us in comparing multiple values against the single record instead of writing or conditions multiple time. If I write like one query, maybe I can say select star from employees where salary is equal to 50,000 or salary equals to 60,000. So this will give me the output. So let me see. So there are no such employee with this one. So let me change it little bit. Maybe I can first see the data. So the salary is like this. Maybe say I can make 86,000. Okay, so this one, let me query. So one record is written, so the same thing I can write like using in. So how I do that, let me copy this first and I'll modify that one. I can write like salary in and then the list of values, so that will also work the same way. Okay, so but there is a limitation using the in, because in the in operator we cannot pass more than 1000 values. Okay, so this also returns the same record. Now let's see between operator also works similar way. So between is same for like writing greater than equal to and salary less than equal to. So this output will be same as writing the between. So this gives me 6 records. Now let me copy this and also I can modify this salary. I can write here between this and I don't need to write again the column and this. Okay, sorry. Okay, and this, so this both the values are inclusive, so that's why I said that between operators is same as writing greater than equal to and less than equal to. So let me query it again. So I got the same results. So this is how between works. Now let's see like operator works on a text string. So let me write like this: select star from employees where, maybe I can write like this, where employee name, like I can say I can compare one character where there is a capital B in their name. Okay, so in that case I should be able to get the records. So let me query this. So there's one employee where there is a capital B in the name. So now let me change it to only lowercase b and let's see if there exists some employees or not. Yes, so there are two employees where this lowercase b exists, but there are other options as well writing like operator. So if I write like this b and then the percentile symbol, so that means the name should start with this letter. Okay, let me change it to d, capital D. So the string should starts with D and whatever after that it can be. So let me query this and see the output. So there's one employee that satisfy this criteria where the string starts with D and whatever we have after that. And also we can put like there's other option, so whatever that can be, and then there should be one lowercase n, and after that also there can be many things. Okay, so that's also possible. So that also returns the same result. Okay, and in case of writing, for example, say there is a scenario where the condition is to find such employee whose name starts with B and ends with B. So how we write that? So in that case we need to write like this, we need to change that, we need to write like this, uh, B starts with B and then percentile, that means whatever in between it can be, and at the end it should be B. Okay, so let me query and see the output. So instead of finding all the characters whatever in between, we can also search for specific one. So let's say we want to find, let me see the names first, names of the employee. So maybe for Charlie, okay, we can make this. Let me form a condition that the name should start with C, and after three characters, or maybe I can say for Charlie 1 2 3 4, so the fourth character should be R, lowercase r. So how we do that? So in that case I need to put lowercase 1 2 3, and then the fourth character should be R. Okay, and after that whatever it can be. So after that whatever it can be, I can write like this. So let's see the output in this case. Okay, there was a mistake in the condition, because if I bring out the Charlie, so the string is like this. C is at the first, and then H, then A, then R. So R is at the fourth place. So if I write like this C, and then second one is this A, and sorry, second one is H, and then A, and then R, and whatever after that it can be. That is also possible. So that means writing percentile means whatever it can be, the number of characters can be, and writing underscore, that means only one record it will be, sorry, only one character will be compared. Okay, so this is how we can use the like operator, and also there are operators, so there are other operators such as in, between, etc. And also the negates can be possible. We can write like this, not in. Okay, so it will be not in this conditions. So let me see the output. So the employees whose salary are not in this and this, they will be returned. And also I can write like this, between, and also I can make it not between. Okay, so the salaries whose are not in this range, they will be returned. So they'll be returned. And also in case of like, I can make it not like. Okay, so that is also possible. So I believe apart from Charlie, every records will be returned. So this is how these things work. So we covered these special operators. Now let's see some common PostgreSQL function. So first we starts with string functions. In case of string functions, we will see upper, lower, etc., length function, substring function, trim, and replace. So let's see with example first. So I can write like this, select, I can make upper employee name. Okay, and also I can make lower employee name, and this is the lower function. And also I can say the length of the employee name. Okay, each employee having how much character. And also I can have substring. Okay, substring works like this. So first I need to pass the string or the field name, and then I can make 1 comma 4. So I need only first four character. So 1 is the starting point, 4 is the ending point. Okay, so this is how substring works. And then I can make let me write here, trim. Okay, it trims the data from side. So let me say I can trim like this. I have this spaces, and then hello, and then I have this much spaces. So this trim function will trim the unnecessary space from the output. And then there's a replace function as well. So let me replace employee name. Wherever there is one lowercase a, I want to replace it with, maybe I can say, hash character. Okay, so and then from employees. So let me query and see the output. Now we can see the output like this. Okay, so in the uppercase we can see that all the names are in uppercase. In lowercase, all the names are in lowercase. In the length of the name are printed. And substring, in case of substring, we can see that we have got only four characters of their name. Even if there is more than four characters of the name, then using the substring we can manage that one. And in case of trim, we can see the output here, extra spaces are cut. And also for the replace, we can see that wherever there was lowercase a, they are replaced with hash. Okay, so these are some common string functions of PostgreSQL. Now let's see some common mathematical functions. Mathematical functions such as round, cell, floor, absolute, power, etc. So first let's see with example. Maybe we can say select round. we can write rounding like this. We can have salary and then comma 1. Okay, so up to one character it will be rounded off, so it won't be better, but let me do it divide by 33. Okay, the rounding off will be done on up to one position, one decimal position, and then I'll use the ceiling function on the same thing, salary divided by 33. So let's see, the ceiling function will give the upward rounding of number and the opposite one is floor. So floor will give me the downward rounding of number. Okay, I'll show with example, and then there is absolute. Okay, so in case of absolute, if the value is negative, maybe say minus 40, the absolute value will be positive 40. And then comes the power function. So power function, it gives the power like this, 2 to the power 3. So we know the output should be 8. So now let's see the output, and this is from employees. Okay, so let's see the output. So here is the output. So let's see, so in case of rounding, the salary when divided by 33, it can be any number, but let me show you that also. So salary divided with 33, it would be very long number with decimals. So here it is. So if you see salary divided by 33, it's like this, but when I do rounding off, it is rounded off up to like this. Okay, dot 2. Why? Because 18 is rounded off to 2. And ceiling, if you see, it takes the next whole number. So in case of 2618.2, the next whole number is 2619. In case of floor, the next downward whole number is 2618. And in case of absolute, the value was minus 40, so the output is plus 40. And in case of power, 2 to the power 3, it's 8. So this is how some mathematical function works, and we covered them with examples. Now let's see some date and time functions of PostgreSQL. So we have functions such as current date, current time, etc. to get the date and time information. There is age function to get the age between two dates. There is a now function to get the current timestamp with date, and there is extract function to show the particular date portion of the date value. So let's see them with example. Maybe say select current date, so this will give the current date, whatever is the date for today. And now let's see current time, so this will give the current time with time zone. And let's see the age, for age we need to write like this. Maybe I can make two age, let me provide in the form of year, month and day. So this is 2026, the day is 1st of January, and then comma the second number. So the second number can be 2060 and 0101. Okay, so this will give me the age. The difference between two date values will be in age, we'll see. And we can also have a now function. So now function will give the output with time, with date and time. Okay, this is the current, this will give you the complete data of date values. Now let's see extract. Okay, extract will help us extracting a particular value from a date. Maybe say I can extract year from current date. So let me write like this. Okay, so the year is 2026, that will be extracted with this query. So let me query this and see the output. So these are the outputs. When I write here current date, so current date is 5th of May, sorry, the current date is 1st of May 2026, and the current time is this much, 15:29. And the age is in the negative because the first age is in the lower range, so that's why it became negative. And then the now, so now gives me the current date plus current time, so this is the mix of them. And the extracting year from the current date, it's 2026. So this is how some date and time functions work in PostgreSQL. Now let's see typecasting. Okay, so typecasting is also very important. We'll see with examples. So typecasting means converting one data type into another data type, and that should be compatible to change. Okay, so let's see with examples. And PostgreSQL supports two methods of typecasting, using operator and using the cast function. First we'll see one example using operator. Okay, so let's see how it works. So for example, I can write like this: select, and I give one number. So this is 123. This is a text. If I query this, so the data type you will see it will be a text value, but I can convert it using double colon, and then I can make it as maybe say integer. So this is how typecasting work. So if you see, the output is changed into integer. Okay, so this should be compatible obviously, but if I say 1 2 and then B and C, etc., so this will not be casted because this is not supported. So see, so the data is not compatible to be typecasted into integer. But yes, if I cast it to, say, I can cast it to character varying, it should work. So let's see the output. Because it is compatible to be changed to character varying, the text value can be changed to character varying, so it was typecasted. Some other examples we can see, such as this is 100, so this is integer. So if you see, this is integer, but I can typecast it to text, so this also works. So the output will be text. Okay, and also I can typecast the value to date. So let's see, select, maybe say I can say now. So this will give me the current timestamp with time zone. Okay, so let me typecast it to date. So this is also compatible. So this is typecasted now, and when it was typecasted to date, so the time portion was removed, only we got only date. And also we can typecast it to text. So let me typecast it. So now the output has come, but in the form of text. Okay, this will be treated as a text value. So this is how we can do the typecasting using the operator. So this is the typecasting operator. This is, this double colon is called typecasting operator. Now let's see using function. So there is a function called this cast that can be used for typecasting. So let's say similar example, maybe we can write like this: select, then cast. Within that we can provide the value. So maybe say 123, and we need to cast it as integer. Okay, so by default within the quote 123 is a text, but we want to typecast it as integer. So let's see. So now this is typecasted. Similarly we can do other things like 123.96, sorry, 86. So let me see how it is typecasted to integer. So this gives error because there's a decimal point and it cannot be typecasted to integer, but it can be typecasted to numeric, because we know numeric can hold the decimal values. So see, the data type from text is has changed to numeric. So similarly we can typecast other values as well that we have seen using the cast function as well. Now let's see one practical example combining operators and functions and typecasting. So let's see an example writing a complex query using the employees table. So in that case I'll write select. First I'll take employee name, then I'll take salary, and then I'll take maybe I can compute salary like this: salary multiplied by 0.1, that's the 10% of salary, and I want to typecast it as numeric. Okay, numeric, and I can mention here and how much the numeric can be. It can be 10 comma say 2. Okay, and it would be like bonus. So that means salary of 10% of salary is called as bonus. Okay, and also I can extract some year or date value, etc. Extract, I can say year from the now. Okay, from now I can extract the current year, so I can mention here this is current year. That means which year we are getting the bonus, and then I can end it, and let me write this from employees. Okay, so let's see the output. So this is the output. So these are the employee name, then the salary, then the 10% of their salary is known as bonus, and then the current year. And this completes the module of typecasting operators and functions in PostgreSQL. In the next module, we will cover the topic of importing and exporting data in PostgreSQL. So let's move to the next topic. Hi everyone, in this module we will see how to import and export data in PostgreSQL. In this video particularly we will do it for single table. So first we will do it using pgAdmin tool, then I will take you to the terminal how we can do it using commands as well. So using commands is very helpful when you work with the cloud architecture or the client's machine. So first we will see how to export the data from the existing data. So for example we will export the data of employees. So you can select in the pgAdmin the employees table, right click on that, and then you will see one option here of import export data. So select that. Here we are going to export the data, so select export. In case of import you can select import. So but now we are going to export the data, and this is the path where I want to export, and you can give one suitable file name. Because we have selected here format as CSV, so I'm providing the file name as .csv. And in the options you can select the header, if header you want to be there or not, and also there's option to freeze. So those things are not required as of now, so just have default things. And here if you see the columns that are going to be export, you can select them or you can leave them. So by default all the columns will be selected, and now let's click on OK. So if you see process started and process completed. Now let's go there and see. So this is the path where I have exported the data, and I can see the data here. So this is the data we have just exported to our machine. Now let's do importing of the data. So to import the data, what I'll do, I'll create one dummy table, create a table, maybe say I can say employees 2, okay, then as select star from employees where 1 equals to 2. Why? Because I just want the structure of the employees table and not the data. So create table employees 2 and then as selected from employees where 1 equals to 2. So that means no data will be copied. So the table is created. If I refresh you and show you, so this is the table. So this is the table that employees 2 created, and also I can show you the data. So there should be no data because I have created only structure. So select star from employees 2. Now let's query this. So there is no data. Now I want to import the data into this table. So right click on that table, then again go to import export option. Then this time we need to select the import. So let me copy the file name with path, and then I can provide here the path. Okay, and this is the path I have provided from where I want to export the data, because in this path I have the backup. In the option there is no header because in the file there is no header, and in the columns, so I need to have all the columns. So let's click on OK. So the process started and process completed. Now if I query, I should be able to get all the data. So here if you see that I have got all the data, so that means we have successfully imported and exported data for one single table. So now let me delete the data for this table because I want to show you how to do it using the command as well, PSQL tool. So there's a tool called PSQL. When you install the PostgreSQL, this tool also gets installed automatically along with the pgAdmin. So go to your search machine here and then type PSQL. So here is the option that we have to open. So just click on OK, and then we need to select the server. So for us it is localhost, and then the database. So in this case it is not Postgres but the first DB. Okay, so we are connected to the first DB server. The port is 5432 and the username is also Postgres because this is the root user, and the password is root. So this is how we have connected. Now we need to set the search path to school schema, search path to school. Okay, the search path is set, and also we can view the data from here. Select star from, I can say the data should be employees. Okay, select. Okay, so there's a mistake. select star from employees. Okay, so let's see the data. So this is the data for employees table. Now what I need to do is let me delete these things first. So I have deleted. Now this folder is cleaned, and what I need to do is I want to export the employees data as CSV. So the command is very simple. So let me paste it here. So this is the command. So the command is very simple: slash copy, then the table name what you need to copy, to to2, then the path and your file name, and here I have mentioned CSV with header. Okay, so let me enter. So it says that copy of 10 records is completed. Now let's go there and see. So this is the file that I just copied here. So if you see here, we have the employees data along with the header. So that means this copy has happened with this PSQL tool. Now what I need to do is I need to reload this data into the employees 2 table. So I'll again write this command, but we need to change here. So we need to change this command employees 2, because we are going to copy the data to employees 2 table. So instead of writing here 2, we need to write here from and then the file. So this is the file from where we want to copy the data into the employees 2 table. So let me press enter. So the copy is completed. Now if I want to see the data, I want to write select star from employees 2. So we have got the data into the employees 2 table. The same we can confirm here as well. So let me write select star from employees 2. So here is the output. Okay, so this is how we did import and export of one table data using pgAdmin, and also we used one new tool, that is a PSQL tool, and we did copy and export of the data using PSQL, where we imported the data into employees table and we exported the data from employees table. So these were some basic import and export options we have. So for now you need to learn about this much only. When we cover advanced things and the administration part, I'll show you how we can copy and load and etc. do everything, the entire database. So I'll cover these things later. So in this module we have covered import and export of data. In the next module we'll cover the topic of basic administration in PostgreSQL. So let's move forward to the next module. Hi everyone, in this module we are stepping slightly into the administrative side of PostgreSQL. In this module we'll create users, we'll assign roles and privileges, and perform basic backups and restore using command lines and as well as pgAdmin tool. So first we'll start with pgAdmin tool. So let's take backup of this first DB database. Okay, so you need to select the database, which database you are going to take the backup. So right click on that and then go to the backup option, select backup, and here you need to provide a file name. So let me select the path here as well. So in this path I'm going to provide one file, maybe say first db. Okay, and then I can click on save, and here in the format custom to I can make plain, so that I should be able to read the database, and this database is going to be created as firstdb.sql file. So click on backup. So the process started and then process is completed. So here if you see that in that path the first db.sql backup is created, I can open that and here we can read all the documents. Now I'll tell you how to restore that backup. So for that let me create another database called firstdb2. I can create firstdb2, and this is how I created the database. So the first db2 database is created, but inside that if you see there are only public schema and no tables and nothing. So let me show you. Okay, there is no table etc. Now I want to restore the backup. So right click on the newly created database and then go to restore option. Okay, click on restore and you need to select the format. So in this case it was plain directory, sorry, it was plain file, and then select the file name. So file name we can select from here. You need to change that backup from all files. So this is the first db.sql. Select this file and then click on restore. So the process started and process is completed. Now let me refresh this. So I have refreshed this, and when I expand this one I can show you. Wait, this is the public schema, because all the objects were in school database, school schema. So in the school schema, if you see, we have the data here, and also I can show you some data from here. So these are the data that we just restored into the first DB2 database. So this is how we can create one backup of our database, and also we can restore that database. And also I can drop this database. As of now this is not needed, so the database is dropped. So now these things we have done using the pgAdmin tool, that is the GUI tool, and also it is possible to do it using command line. Suppose you don't have this pgAdmin tool facility, so how you can do that? So for that you need to go to the bin folder of your PostgreSQL server. So for me this is the path, and if you have installed the PostgreSQL with me, so you should also have the similar path. So you go there, and if you see here, there should be pgdump all. So this file must be there, and also there should be pgrestore. So this is here. So that's why we are going to this path, and then we open cmd, that is the command prompt. Okay, now we have opened the command prompt on this path. Now I'll show you many ways how to do that. First I will show you how we can dump in the format of .sql file. Okay, so for that this is the command pgdump, then -s for host, so it is localhost, -d for the database, which database we are going to dump, and -u for user, so user is Postgres, and -p is for port, that is the default port 5432, then -f the file format, it is the plain, and then this is the path where I want to take the dump. So let me take the dump. So it's asking for the password for the root user, that's the Postgres, so password is also root. So I have provided the password and process is completed. So I can see, so this was the path that I had provided. If you see here, so in that path our first DB database is backup created. Okay, so this is how we can take the backup using the command line. Okay, the pgdump command was used. Now let's do one thing. Let me create this first db2 database again, because I want to show you how to restore the database using the command prompt. Now I'll show you how to restore a database from SQL file. So for that this is the command psql. Okay, so remember this thing, when you restore your database as a SQL file, that is you have a backup as SQL file, and from that SQL file you are going to restore using command line, then this is the tool. psql is the tool, psql is the application. Okay, and then remaining things is similar. -s is for the host, -d is the for database and user, and then port, and then from which file we are going to restore. So this is the same file that we had just taken the backup. So let me restore. So it's asking for password for Postgres user. So restore is completed. If now I go to the first db2 that we just created, let me refresh it. So after refreshing, if you see in the schema section, we have here school schema, and also we have the tables, views, etc. that we had in our first DB. Okay, so this is how we can restore database and take the backup of database using command lines. So this was for SQL format. So there's other format, that .backup format and .tar format, that is the tape archive format. So we can take backup in multiple format and restore in multiple ways. So in this tutorial I'll show you how to do for .backup. So let's go to the command line and I'll show you how to do that. To take the backup as .bak file, so this is the command pgdump, then host, then db, which db you want to dump, the user, through which user you want to connect, and then -f for file format, then c, it is for custom, and then .bak. So let's do it. So it's asking for the password, so password provided. Now if I go to this path, so here is the backup created as .bak. Now I want to restore this backup. So for that, let me create the first db2 database again. The empty database is created. Now let me do the backup. So to do the backup using the .bak file, so this is the command. We can use pgrestore. Okay, so using pgrestore we can do the backup. So remaining things is same that we have been using. So -d is first db2 the database, and then the file path and the file. So let me enter the password. Password is root. The process is completed. Now let me refresh this first db2. So now if you see, we have backups restored. Okay, so this is how I have shown you how to do multiple ways, how to take the backup and how to restore that backup successfully into your server. So this is not required, so let me drop this backup again. Now let's move to the some administrative things where we create user in PostgreSQL. So let's select the first DB database. Okay, search path is set. Now let's create some user. In PostgreSQL, every person or application that needs to connect to the database must have a user account. So we also call it as role. So roles can log in, own tables, create databases, have privileges of select, insert, update, etc. And let's see how to create a user first. Creating user is very easy. Write like this: create user, then the user name, and then with password. The password can be root. Okay, so this is how we can create a user. So let me create the user. So user is created. Now if I let me expand this and refresh, so here it is John that we have already created. Okay, and if you notice there is a main user, that is the root user is Postgres. Okay, so now we have created the user John. And how we drop a user? We can drop user like this drop user John. So the user will be dropped. So this is how we create user and drop user. So the user is dropped. Now we can also create roles. So how do we create roles? Role can be created simple: create role, and then maybe say I can create read only role. Okay, so I'm creating a new role that can be read only. So I have created role. Let me create the John again. So user John and read only, they are created. Let me refresh it. So here if you see, read only role is created and John is created user. So what I can do is I can assign John with read only, means I can associate them. The role that whatever I am going to give this one, so John gets that role. Okay, so I'll give some access to read only, etc. So let me give grant. So here is how we give the privileges. For example, say grant connect on database is say first DB, and then we can say to read only. Okay, so this is how we can give grant to the database, so that this read only, using this role, the user John can connect to the first DB database. Now let's see how we can add user to this role. So that is also very simple. We need to give grant. Okay, grant read only, then to which user we want to give, to John. So let's do it. Now let's see some commonly used privileges that we mostly used in case of PostgreSQL privileges providing. So we can give grant, maybe we can say select, and we can give on table, that is employees, to John. Okay, so this is how we are granting that okay, John can select data from employees, or we can write with comma that we can insert and update, etc. Update but not delete. So if we provide this much grant to John, so John the user will be able to perform this much action on the employees table, but he will not be able to delete the data because we are not providing that access to John. Okay, so this is how we provide the access. So let me provide it. So this is done. Now also it is possible to revoke the grant. So how we can do that? I can write like this: revoke. Okay, it is done using the revoke command. So we can revoke on employees, okay, from John. Okay, so I'm taking all the grants that I had just provided to John from that table employees. So now the grants that I had provided to John, they are removed. So this is how we can grant some access to user, and also we can revoke the access. I have already shown you how to drop a user. We can similarly drop a role as well. So write drop role. The role is read only. So let me drop. So the role is dropped, and also I can drop again the user, drop user John. So the John user will also be dropped. So they are dropped. Now if I refresh them, so they are not present anymore. So this is how we created users and assigned roles and privileges and then revoked the privileges. And also in this module we saw how to take backup of the database, etc. But there's one more thing that I'll show you, that for example, say you want to take the backup of all the databases in your server. Okay, so in this case we have two database. If you see, first DB database and Postgres database. So is it possible to take all the backups? There can be maybe more than 30, 50 or whatever databases. So is it possible to do at once? So yes, it is possible to do that using dump all command. So for that, let's go to this command line again, and this is the command that how we do that. So it's pg dump all the host, and here if you see, we are not mentioning the database because we are selecting all the databases, so we don't mention any database. Instead of using the pg dump, we use here pg dump all and hyphen localhost users and then port and then the file, so where we are going to dump this. So let me enter and the password. So the process is completed and the backup must have been created. Let me show you. So if you see, here is the backup. So the backup is created like this. Okay, so this is how we saw many things, many basic administrative things of PostgreSQL. So this was all about this module. In the next module I'll explore pgAdmin and I'll show you the options that we have using the pgAdmin. So let's move forward to the next module. Hi everyone, so this is the last module that we are going to discuss. In this module we will see the pgAdmin tool. So we will explore the options of pgAdmin tool. So in this module we are going to create databases, tables, schema, etc. using pgAdmin. Then we will run some queries using the query tool that we have been already doing, and then we will view data and the structure using pgAdmin, and then we will export data results using pgAdmin. So let's start. So when you open the pgAdmin, the first thing you will see is the browser panel on the left side. So here if you see these are the browse panels on the left side. So this is where all the server databases, tables and objects are listed. So let me first connect to the database. If you are not connected, so you can expand this and connect. So if you don't have this server already created or linked to you, so you can always create one or register the server here. So from here you can provide options and connect to the server. But in our case we have already installed the PostgreSQL 18 server, so we have this server. Now click on expand. It will ask for password. The password that we had set, it is root, ROOT. So click on OK. So this is opened. Okay, now we have our first DB database, and we have these are the databases we have already created and we have worked on. Now let's create a new database. How we can create a new database? So for that, select the databases section and right click. So go to create and click on database. So the database creation option is here. So we can create here new DB. So like this we can create a new database. There are definitions. What are the definitions and options we can provide here? We can select the table space, etc. But now we are providing everything as optional. Just provide the name here, the database name, and then create the database. So the new database is created. When the new database is created, everything will be blank except one public schema by default is provided to you. So you can either use that schema or you can create new schema. So we always created a new schema while working. So let's create a new schema. So how we do create a new schema? So for that, right click on schema, go to create section and then select schema. So schema we can say, I can say test schema we can say. Okay, so and there are other options as well, but we leave them as it is and then we click on save. So the schema with the name test will be created inside the new DB database. So this is how we created database, and we also created a schema. Now let's create table using pgAdmin tool. So we have created many tables using the query tool, that is create table command, but let me show you how we can do that using the UI. Okay, so in that case, go to expand the test schema that we just created, go to the table section, right click on table, go to create and then select the table. So this gives you option to create the table. So I can say maybe same employees table. Okay, and on which schema we are going to create. It's test schema, and then we need to provide the columns. So let me select with plus icon. I can say emp id the first column name, and the data type I can select. It can be, I can search here. So this is the serial, and the length, precision, etc. is not required. It should be not null, it should be primary key, correct. So I have selected primary key. When I have selected primary key, not null is by default, so it's not required to do. And then I can do plus, and I can also provide emp name, and from the data type I can provide, say, character varying, and the length it can be 30. Okay, and not null, check it is. And then I'll create another column, salary, and salary should be numeric, so it is numeric. The precision we can say 10, and the precision should be, the scale should be 2. And then with the plus, and we can create department id. The department id must be integer, so integer option is here, integer. Okay, and this also should be not null, sorry, this can be null, and salary must be not null. Okay, so this is how we can create, and there are other options as well. For example, let me say, for salary I can edit this better, and we can have many other options as well. I can provide comment for this as well, this column, etc., that why I am creating this one. And in the definition section I can see that I have provided this much. And let me provide one constraint. Okay, we can provide constraint here as well. So this is asking for any default value. Say maybe we can provide default value as 100. Okay, and these are the things that we have provided here. So let me save this. Okay, so when I save this, this will create one table. But before going that, let me show you the SQL. When I do create a table using UI on test schema, this is the employees table. So these are the column, and these are the things that we have provided. For salary, if you see, we have selected numeric 10,2, and it should be not null, and we have also provided a default value of 100. Okay, so now let's save this. So the table is created here, the employees table. Okay, now what we can do is we can insert some data, or we can query some data that we have been already doing. So let me show you from the already existing data that we have. So in the first DB, we know in the schema section, for the school schema we already have many tables and data. So I'll use the employee table again. So how we can run the query, or how we can view the data from here. Okay, not writing the query. So right click on that, and then go to view or edit data. So how you want to see the data, all records, or first 100 record, or last 100 record, or filter record. So here we can provide the filter as well. So for example, let me say I can see all the records. So all the records are written. If you see here, this is the command that executed behind this, and all the records are written here. Okay, so this is how we can use this one. And also we can run this query using the querying tool. How we do that, I had already explained you. So this is the query tool. If you click on this, one query tool will be opened up. So let me do this. So search path is set, and now I can query. So this is the data. So this is how querying tool let you query the data from database. Okay, I'll also show you how we can export the result set. So for example, this is the result set that we have for employees table. When you query from the employees table, so this is the output, and now I want to save this data as output. So there is an option to download here, so you can save the file. Okay, so here how I can save. So click on save then. So this is the file that we just save, and we can open and view the content as well. So this is how we can export result sets into external file. So now as we have seen the data, etc., and also it is possible to see the data structure, that how the table is there, and etc., the column data type, etc. So just select the table that you want to view, and then scroll. So these are the columns we have, and the data type, etc. And for that table what are the constraints there. So we know there's a age for there's a check constraint on age column, then there's a department id is foreign key, then employee id is the primary key, and then there's another check on the salary column. So this is how we can see the details, and also we can see the indexes when we had created indexes, and if there is any row level security policies objects here. So if we had created functions, then we should be able to see the functions and other things. So this is how pgAdmin lets you see the data structure and details of your table that we have created. And same thing we can do for views as well. Views we had created, so if I expand this, I can see the columns that we had in this view, and if there is any trigger, etc. So we can do that. Okay, so this was some basic things. So there are lots of options and possibilities using the pgAdmin UI. This is a very good tool. As you know this much about pgAdmin and PostgreSQL, I believe you are expert now in using pgAdmin tool and working with PostgreSQL. So this was all about the PostgreSQL for beginners tutorial. I believe you have enjoyed it and you have got some value watching this tutorial. And I ask you to like the video if the tutorial was helpful, and also subscribe the channel to get the notifications. I have also created other tutorials such as PostgreSQL for intermediate. As you have already completed the beginner level, you can watch that. And also there is a tutorial for advanced learner. So if you want to be expert in PostgreSQL, you have to watch that, where I have explained all the PostgreSQL options in very detail. So signing off from this tutorial, I believe we can meet in some another tutorial. So till then, take care, bye bye.